You want me to... Okay, testing. Do you want to give it... All right, welcome everybody. Great. Well, it's a really exciting event. This is probably the biggest event we've ever had. Really excited to be here tonight. So, first of all, maybe a big round of applause for Google for putting on this great event. And welcome back to 2014. We're going to kick it off with, I think, a real bang. It's going to be 4 talks and a panel Q&A discussion. And before we get into that, it won't take too long, but I wanted to just talk about a couple of quick things and thank the sponsors also. So HTML5 San Francisco has grown by 3,500 members in just last year alone, and we're at close to 9,500, almost at 10,000. So tell your friends and we can hit that 10,000 mark pretty quickly. I wanted to also let you know that all of these talks, like for example tonight, we're live streaming, but all of our talks are always recorded. So we've actually had an archive of all of the different talks we've ever done, with the exception of one that got corrupted. And that's at bit.ly SFHTML5 video. So check that out. And if you need to catch a video that you couldn't come in person, or if you're on the wait list with 500 people, then there's always that chance. So tonight, we have a couple of prizes that we'll talk about. We also have a prize for the best tweets and social media exposures, and some nice wine prizes for that. So WebGL, SFHTML5, use those hashtags tonight. We just finished our survey. Every year we do an annual survey. We ask just a few questions. Definitely join that next year. We had some really interesting results, and we're trying to tailor our content to exactly what you need. And so we got some very interesting feedback from you, mostly in line with what we expected, but there were some surprises in there. And for example, we had security came up as a top topic that people wanted to hear about. So check it out at the bit.ly SFHTML5 Annual Survey 2013. Pretty long, short link. But some interesting stuff in there. One of the things we're in the process of for 2014 is we're going to be offering childcare for people that can't otherwise come to the meetups. The details will be coming, but that's something we're really excited about, and we'll be rolling out this year. So exciting stuff. Okay, one of the sponsors is the Google Developers Live channel. There's some great content on developers.google.com/live, and then you can also find Chrome and web-specific stuff on the /Chrome channel. And right now we're doing a series of office hours every week for the launch of our new course. So we just launched, we already have a lot of people signed up for the Udacity mobile web dev course, and that's something we're really excited about. We worked together with Sean Bennett, who's in the room, Chris Wilson, to create this course to really teach people on the best practices of mobile web development. So check that out. The course is on the Udacity site. You can check us every week on Tuesday morning at 9 o'clock. We are there to answer all your questions. So we have, it's on SFHTML5's meetup site. It's on the Google Developers Live site. You can find it there. You can ask questions, and you can vote on questions as well. Wanted to have a shout out for Rocky, my son, who's out there DJing. If you like the music. You can also hire him. Grand Eddy Winery is pouring. They came all the way down. It's about a 3-hour drive, and after this they will be driving back. They won't be drinking tonight, but you will be. So we have about 15 cases of wine here, so definitely try some of it out. It's really good stuff. The first sponsor that I wanted to bring up here is Kazing. Peter, a couple of words.
Thank you very much. Kazing has been a founding sponsor of the San Francisco HTML5 user group. And I'd like to take this opportunity to say a huge round of applause to Peter and Vanessa for putting on these shows month after month in the last 3, almost 4 years now. Thank you, guys. So Kazing is based in Mountain View. We have 60 employees. What do? We have a high-performance enterprise-grade WebSocket server, and we are solving the hard problems of the real-time web communications. Later today, you are going to hear about some aspects of these challenges in the talk after the break. We are hiring. We are doubling our size. We are hiring engineers in various roles, server side, client side, as well as tooling. We are hiring product managers, developer advocates, as well as in various sales roles. So I wanted to thank you guys again. And we are raffling off an iPad mini Retina. So make sure you do have your raffle ticket. And if you are interested and want to talk to us, come. We are right outside the door. We have the orange tablecloth. It's very easy to find us. Thank you.
Where's your orange shirt? Great. Other sponsor wanted to thank Adobe for just continuous support and all of the great stuff they're doing in the HTML5 space. Also have Anne here talking to you about HTML5 DevConf. So save the date. If you haven't been to that conference, it's getting bigger and bigger every year. It's going to be at Moscone again. Come up.
We have two scheduled. Tell us about it. Sure. We have, hey, by the way, thank you, Vanessa and Peter again. We have two scheduled this year. We have the spring in May 22nd, and that's where the one that the call for speakers is now up on, and we'll be sending an email out to everybody. And that will be at the Hyatt Regency, close to the ocean, so that'll be fun. And then in the fall, we have one again at the Moscone. So we're looking forward to that. How many people have been to the HTML5 DevConf? All right. Okay. Okay, a lot of times people find out about things there first, partly because we have a call for speakers. And we don't just keep reaching out to the same speakers over and over and over again. So we actually have this call for speakers. Sometimes we catch some new things in there that we wouldn't otherwise know about. So please, if you have something you'd like to talk about, please do apply. And also, it's just wonderful tonight seeing Tony Parisi. He was somebody that came through Call for Speakers a couple years ago when nobody really cared about WebGL. So yeah, so pretty exciting stuff, and we're excited about that. Please check it out. Apply. We're especially looking for good one-day-long instructors. We got excellent feedback on that in general. Of course, you don't hit everything out of the park, but in general, people were very pleased with that. Good, reasonably priced, one-day-long, in-depth technical instructions. So if you're one of those people, let us know. And if not, we hope sometime you have some sessions you want to share, and hope to see you there.
Good. Thank you. All right. Next up, we have PubNub, another sponsor that just signed on late last year. Tell us about it.
Thank you, Peter. Hello, everyone. My name is Stephen Blum. I am the CTO of PubNub, and we are changing the world. Yes. PubNub's a global real-time network. We're taking humanity one step closer to the singularity. And we power the Internet of Things and things like multiplayer games with real-time WebSockets and technology like that, like for long polling and other things for fallback and web browsers. Just to update you from the things that we've been doing recently, we were on stage with Ford Motor Company at CES talking about IoT, Ford connected cars. We power Mt. Gox. How many people have heard of Bitcoin? Yeah. So you can subscribe to a live feed on PubNub straight from Tokyo from Mt. Gox's C servers. We also have a new website update where you can see JSON messages flying around. So feel free to check that out. We also have a new website, a new office on 3rd and Folsom. On Tuesday, we have the creator of Phantom.js who is speaking. Please sign up at JavaScript Meetup. And we're doing Viva la JavaScript. In high school, I made games using OpenGL and C, and so I'm really excited to see the speakers tonight talk about WebGL and web browsers. Thank you.
Thank you, Stephen. All right, a couple other sponsors I wanted to thank: Bounty Source and Intel. They're not here tonight, but they're supporting us anyway. And we also have a new sponsor, Matrix, and here to tell us about it, Justin.
Hi, my name is Justin Harless with Matrix Resources. Matrix is a $200 million, well, first off, thank you, Peter, for allowing us to be a sponsor this year. And Vanessa, great job putting this together. Matrix is a $200 million technical consulting firm that focuses in three main areas. Technical staffing, so contract to hire and direct hire, as well as professional services, which encompasses development and offshore support. We also do agile coaching, which is an extremely hot topic within a lot of development teams. Nationally, certainly I'm sure in this room as well. So we have some team members outside. If you are a candidate that is looking for an opportunity, we'd love to talk to you. If you're a client that is in need of talent, we would love to talk to you. Front-end developers is a big part of what we're doing every day. So again, we'd love to talk to you outside, and thank you again for allowing us to be a sponsor.
Okay, thank you. All right, just a couple more sponsor announcements, then we'll get right into it. So we have MoBoom as a responsive design, and they have a conference coming up, a free conference. Tell us about it.
Hi there, I'm Jennifer Pristina from MoBoom, and for those of you who may not know who we are a standards-based responsive design platform and adaptive CMS, and our whole goal is to make developers' jobs a whole lot easier. We allow you to use your full spectrum of your skill set, but just a lot more efficiently. So this free event that we're having is February 12th. Mark your calendars. Go to conference.moboom.com for the full lineup of speakers. But we have some pretty great speakers. Jason Grigsby, who's the author of Head First Mobile Web, and also Greg Noodleman, who does UX. So he's coming to do a special UX workshop, and it's limited to 25 people. So sign up if you do UX and are interested. We'd love to have you.
Thank you. All right, another new sponsor. So a lot has happened in the last month or so. Sony. So actually, the second talk, second talk will be Don Olmsted and talking about some of the WebGL stuff that's in PS4, and Sony also here as a sponsor. So tell us a little bit about what you do.
Thanks. Thanks for helping us out and letting us be a sponsor. It's been very great working with you guys. I can't believe you must be busy, but you've been very responsive and helpful. So so we're Sony, not maybe a name that you associate with good web design, but we have made some changes recently. So our team here, we have some of the core developers from the PlayStation 4 team, which you will know by the end of tonight, is built on a WebGL platform. So about half of the UI there is built in WebGL and JavaScript on top of WebKit. So you'll be hearing a lot more about that later. We are also hiring, and we have our recruiters here. We have a bunch of people here from the team that are excited to talk to you and tell you a little bit more about what we're doing. And we'll be auctioning off a PlayStation Vita in the main raffle, and we have another one. We couldn't get you any PS4s. They're all sold out, sorry. The Vita, though, we have at the table out there. Just give us your email and let our recruiters email you, and you can sign up for that Vita. We'd love to talk to you. So, thank you very much.
Thanks, Kevin. All right. Fluent Conference is happening. We have it posted on our website as a cross post, so check that out. That's happening pretty soon. They are offering us some books. And our final quick announcement from Elizabeth from Leap Motion. So we have our final talk from Isaac, and Leap Motion has generously offered the two 60-inch monitors, which are they working right now? Yes? Okay. So the overflow areas have these giant monitors. So thank you for that. And thank you for the prize.
Yeah. Hi, guys. Hi, I'm Elizabeth. I'm on the developer programs team at Leap Motion. For those of you that don't know us, this is the Leap Motion controller. We are a 3D input device for fine motion control. It's just a small USB controller that works with any Mac PC and Linux box. We have a table right outside where you guys can check out our free JavaScript API, our development resources, and check out a controller for yourself. As Peter mentioned, our UX researcher, Isaac, or most of you know as Kabibo, will be talking about how he uses WebGL and Leap.js, our JavaScript API, to make really beautiful and happy 3D web experiments. So Please stop anyone in the Leap Motion t-shirt tonight. Talk to us. Most of them is our core engineering staff, and we are always hiring and looking to connect with everyone in the community because you guys have been awesome to us, and we hope to push the 3D web forward with you. Thanks.
Thank you, Elizabeth. Thanks. All right, so it takes a lot to put on these events and keep them free, and we've made the decision to really, since the beginning, to keep these events free. So maybe one more big round of applause for all the sponsors that help us put these on. Okay, so wanted to bring up the first speaker. Tony is the co-chair from the San Francisco WebGL meetup, which I'm assuming a lot of you are interested in joining and probably should be joining. How many of you are from the WebGL meetup? Okay, all right, nice. So there will be many more events, and Tony can tell you more about those. So Tony is, yeah. Mm-hmm.
Let them know that the audio is better out there.
Okay.
Room, there's a lot of people
Okay.
crowded. It's
Yes.
hot.
Right. So there was a small glitch in the audio earlier, but that has been fixed. So you can now, if you don't like standing, take a seat in the overflow areas where you'll get the live stream as well. So Tony wrote the book on WebGL. Literally. WebGL up and running, and another one coming soon. He will be raffling off a couple of those books, and you can get them signed by the man himself. So big round of applause for Tony.
Okay, great. Hello? Hello, you can hear me? Great. Thank you, Peter. Thank you, Vanessa, for organizing. Many thanks to our hosts, Google, and all the sponsors. As Peter said, I'm Tony Parisi. I run the SF WebGL meetup. Quick little bit about me. You don't have to feverishly write this down. These slides will be on SlideShare, and we'll post the link later. So I've been doing 3D visualization for the web kind of as long as that's been around. It's coming on 20 years now, I have to say. Originally working on a technology called VRML, which many of you might have heard of. Some of you might have played with in middle school. A few of you might have even built something in. And on and off for the last coming on 2 decades, I have been building experiences in 3D on the web with whatever technology was available at the time. So I got very excited in around 2009 when I heard this thing, WebGL, was coming out. And after about a year of trepidation and not wanting to get too deep into it, I sort of finally jumped into it. Year after that, I wrote a book for O'Reilly, WebGL Up and Running. I've actually written a second book, which is an intermediate level book. The first one's introductory. It's called Programming 3D Applications in HTML5 and WebGL. That's going to be out in another month or so. Right now you can get the pre-release online, Safari Online, through Amazon, etc. Enough of a plug, and I do all this stuff and I consult, and I have a little startup in the city that's building 3D technology on top of WebGL. And so with that, we live in a 3D world. People move and they think and they experience in 3 dimensions. These days, a lot of our media is 3D as well, though most of the time we experience it on a flat screen, right? But the games we play, the movies we watch, even if you remember back to, 2008 election, the broadcast media we see with Wolf Blitzer stumbling around a virtual set awkwardly, this has become a sort of staple of broadcast media now. This is all done with 3D graphics, which has been done on computers for many, many decades. Historically, it's been with high-end, dedicated hardware and very expensive proprietary software. Well, not anymore. Now, the hardware you use to render 3D runs on this phone, it runs on this desktop, it runs on this Kindle Fire HDX. It runs everywhere. 3D accelerated hardware is everywhere and powers these real-time 3D experiences we're going to talk about today. More importantly, the software to create and experience this stuff is not only accessible everywhere, it's free. It's called a web browser. See if I have audio. Do I have audio on the presentation here? There we go. Okay, so this is 100,000 stars. This was a piece that was developed by the Google Data Arts team. last year. It's been around for close to a year now. But to me, it illustrates the strength of HTML5 as a platform and WebGL, which is what we're going to talk about tonight. Now, if you look at this, you'll see that I'm interacting in real time with a 3D presentation that is running in my Chrome browser. And I can click on a link, and it's going to zoom me into the sun. I don't know what is going on with this little rectangle here. We're going to ignore it. That is craziness. What's going on there? Is that my AV? I'm going to try that again. There we go. All right, so you see this virtual fly-through of our Milky Way galaxy. So imagine trying to build this 5 years ago. You would build this title, you would distribute it on a CD-ROM or DVD, right? People would maybe go into Best Buy or order it on Amazon. And if you built this, the data for it would have to be licensed. See, I don't know what that tile is. We're going to just skip this. Data for that would have to be licensed. And if you wanted to update it, you'd have to go get another CD. We're just going to let this play. I'm sick of looking at that tile. But now it's running in a web browser. And I don't know if you noticed, but when I clicked on one of those links, I'm going to try one more time because I'm brave. There we go. That's scraped from Wikipedia. So we didn't have to go get that stuff from Britannica or anything like that. So the world is our encyclopedia. This Encyclopedia Galactica that's been built was all built on HTML5. This is now a rich media platform, and that's what we're going to talk about today. Back to our PowerPoint. And so I don't know who's seen this. So that was a nice visualization application. But what we're going to see here, I'm going to bring up Firefox for this one because it runs this screamingly fast. And hopefully it's in the browser cache, kind of big content. This is an Epic Games Unreal game that was converted from their C++ code base, including an embedded programming language interpreter. It was actually cross-compiled using a technology called mscripten, compiled to JavaScript, and running in your web browser. We are now live with a full Unreal game level in JavaScript, rendered in WebGL. Let's go full screen. I'll WASD around a little bit, using the keyboard to navigate, use the arrow keys to kind of change my camera control. I'll just go into autopilot here so you don't see me driving and futzing around. But look at this. Benchmarking, we're getting 30 FPS, and we can get higher than that. I think that's probably because of the display sync and everything else. But, you know, fast machine, you get 60 frames a second. Running in your browser, I don't know, it's probably about 20 megs of content coming in to download that level. That was a full Epic level. I mean, we're talking AAA game stuff running in our browser now. And that is all because we have WebGL. What is WebGL? It's the 3D API standard for the web. It's OpenGL ES. Do people know what that is? That is the software API that runs on this phone. And it runs on embedded systems, small devices. That's what the ES stands for, embedded systems. You program to it using JavaScript. It's shipped pretty much everywhere. After initial reluctance by Microsoft, they've included it in Internet Explorer. It runs on the Kindle Fire HDX like a bandit. I can show you this stuff later. Beautiful device, 7 inches of pure happiness, running 60 frames a second 3D. I love this thing. And supported everywhere except mobile Safari, but there are solutions for actually building HTML5 WebGL applications. I'll talk about them shortly for iOS. But on Android, you can use a browser, or you can build a web app, Kindle web app, and on the list goes on. And in fact, it's coming soon to a Bang & Olufsen TV powered by Opera. How about that? On your TV, too. So how does it work? It's an API. It is not a tag set. It's not CSS. You don't put a little, angle bracket and say cube and see a cube on the screen. That'd be nice. Maybe that will happen someday. So it's sort of like canvas drawing. Has everyone done 2D Canvas API drawing, are you quite familiar with it? It's like that, but different at the same time. It's a low-level thing we're going to talk about in a minute. So no DOM. You got to deal with that stuff yourself, just like with Canvas. When you want to deal with picking, you have to kind of make that stuff up as you go, or use some tools, and I'm going to show you those. And there's no file format built in. You know, I've seen so many people ask questions online about how do I see my OBJ files or my other 3D models in WebGL. Well, it's a bit of a modeling error because WebGL itself doesn't support those. The browser doesn't know how to load a 3D file natively and just show it to you. You have to write code. But thankfully you can, and thankfully you can do it in JavaScript and it runs fast. So we're going to quickly go through the anatomy of a simple WebGL program. Breeze through it because there's a lot of details to it we don't have time for. But the basic idea is you create a canvas element on your page just like you would for 2D drawing, but then you get a 3D drawing context where you get that 2D context, you get a 3D context. You create a viewport which basically says the size of the rectangle to draw into. And then from there it gets a little weird, and we're going to go through it. All right, so this is the kind of code, if you're familiar with it, for you get a canvas element somewhere, we pass that into this function, and it calls getContext. And it says, can I have a WebGL context? Older browsers, you have to say experimental-WebGL, but generally this is supported now, WebGL. If you don't succeed at that, you probably don't have WebGL support, and you put up some kind of friendly message for your user or do something else to fall back. And then you initialize the viewport. In this case, what I'm doing is I'm going to draw to the whole window. Then you have to create buffers of data to represent your 3D objects, arrays of numbers in JavaScript that you then turn into this special new thing called a typed array, which you may have heard of at this point. This is binary data that's very compact, runs very fast. It was introduced into browsers a few years ago, largely because of WebGL. And that means your 3D data, which can be very rich, is stored very compactly, and you can operate it on it quickly. The other thing you have to do, which is a little new if you're a web programmer, is you have to create things called programmable shaders. If you know OpenGL ES already, you're familiar with this. You have to write code in another programming language called OpenGL SL, which is for shader language, and it looks like C, sort of. So if you're a C programmer, you'll be kind of familiar with it. And then there are some built-ins, if you look here. It knows about matrices and vectors and 3D thingies already, because what happens is that language gets compiled, and these compiled instructions actually get sent to the graphics card, and they're executed on every vertex that's rendered on the screen, every pixel that's rendered on the screen, and the hardware just does it super fast. This kind of technology came out of Pixar back in the day. High-end renderings now brought to every machine on the planet. That's a little weird, though, a little strange to deal with, but we're going to talk about how we can avoid that. And then we get into some real weeds here, which is you got to do a lot of low-level stuff. GL itself, the API, is kind of a state machine. So you say, okay, that buffer I created earlier, now I'm going to set it, and then I'm going to draw with it. And so we go through and we do that. We clear, this is every frame, you know, you're doing a request animation frame kind of draw loop. We clear the canvas, we set up a shader. Those buffers we created before, we set them up. We have to pass matrices in to move our objects around. All this sort of complicated stuff, right? So you may be wondering at this point, how am I going to do this? Really? Seriously? Well, if you are a game programmer and you're a graphics programmer, you're probably familiar with how to do that level of OpenGL coding. You're good to go. What you'll do is you'll build your own engine for your project. Most people, though, won't do that. And the good news is you don't have to, because WebGL is an open standard, because JavaScript is fast enough. People have written a whole bunch of libraries now that can actually talk to WebGL and make things easier for you. And we're going to see some of those libraries in action in a second from me. One of the presenters tonight, Goo, has actually got a great engine with a creation tool that comes along with it, so you not only have an engine, but you can build with it. But there's a long list, and you go online and you can get these resources from me or other people about where to start in your creation process. Unless you're a glutton for punishment or you really, really want to get to the low level, you're probably not going to do the stuff I showed you a second ago. You're going to use one of these engines and toolkits. And one of the ones I'm going to talk to you about now is called 3.js. Who's heard of 3.js? You use it every day. Good, everybody, that's great. So all that funk we saw before, the 8 pages of code, it was about 300 lines if I counted, we get it onto a page now. And we're now working with objects that if you've got any familiarity with 3D graphics, or you can kind of get up the learning curve fast, they're the kind of objects you'd think about. It's a cube. It's a camera that's got a position in space. It's a light that's going to cast onto the object. You can see some shading here, right? So that's the kind of stuff you're probably going to, the level you're probably going to work at and the kind of stuff you're going to be doing most days, right? 3JS is really cool too because it's got a canvas renderer, an SVG renderer, a CSS3 renderer. It is a great engine. I personally use it for my projects, and then I built a framework on top of it to make that development even easier, because what 3JS doesn't do is a lot of high-level behavior stuff, picking, and other things. You kind of have to do some grunt work. So I've added a layer, but this one is pretty great. And some amazing things have been built with it in the past. I'll quickly show you this one right here, which is the 360 car visualizer, it's called. There we go. So this stuff's in browser cache, ought to load pretty fast, but even with a clear cache, it loads pretty quickly, and we have a beautiful interactive model with a real-time shadow. And this is great. I mean, wonderful, right? I got a 3D model here. I can spin it around. That's excellent. But what's most excellent about this is, I mean, I can really configure this thing. This is an interactive application. I'm going to switch to another model. I'm going to change colors, right? What online car configurator would be complete without being able to select your colors, right? So amazing. And there's a lot of polygon detail in this thing, right? And a lot of beautiful shadows. And the lights are baked into the scene, this stuff here. So that's part of the texture map, the bitmap on the floor. But everything else is being done in real time, including the shadows. Oh, yes. Let's go back to Canary. We're going to show one more demo of something fairly amazing. This one was also done by the Google Arts team, Data Arts team. Completely different from, that was prosaic, right? We had a real-world physical object we were showing. This one's about data. This is about looking at the small arms trade around the globe for the last 2 decades. Now, it's kind of a sobering thought, but it's very interesting. So I can actually slide these sliders and go to different periods of time and look at the progression of the arms trade. I can look at just imports or just exports. I can actually zoom into detail on a certain country, like the Russian Federation, and see how they've been dealing the last few decades. And this was all built on an open source Google Globe project as well. So you could go take the data from this, or the code from this presentation, put your own data in. Let's say you wanted to look at the epidemiology of, help me, what's that virus going around right now everyone's freaking out about? H1N1, thank you, right? Maybe you can see the epidemiology around the planet of that. So this is the kind of experience we're talking about WebGL being able to power. But it goes beyond just, creating the models. There's all this amazing animation stuff you can do with it too. You can do morphs and skins, real-time characters. And how do you do that? That's a good question, I asked myself. How do I make content for this? The state of the art right now is a little bit like we've moved from the stone tools age of creation to the Bronze Age. We're getting there. The tools are coming. You're going to see Goo Create tonight. That's a step in the right direction. What people are doing today in these projects I showed you are they're exporting a single model, an OBJ file or an STL file or one of these 3D formats that's been around for a long time, and then they're hand animating it. They're hand laying it out. They're putting the lights in. You basically like, your modeler's sitting in one room and he's like, Steve, yeah, I put the light over here, and he's talking to the programmer and he's typing the things in a text editor again. Well, that's changing. That's changing. There is a format that was pretty rich and popular for a while called Collada that took all the data, the animations, the scenes, the lights, the full hierarchy, all this stuff, and got it into these big fat XML files. And we've been using that to show some really sophisticated WebGL lately, but the problem is they're big fat XML files. They don't load fast, and they're not tuned up for WebGL. So there's this other cool thing coming, which I'm involved in personally, and we're going to see a lightning talk from one of the creators of later, which is called GLTF, the GL transmission format. So imagine that same kind of rich data being able to fully get into your browser real quick, because all the vertex data is in typed arrays. Only the stuff that makes sense to have in JSON or high-level data is in there. And let's see if I got a link to this puppy here. Love to show you this real quick as my last demo. Yes. So saw on the load screen the 6 megabyte model loaded in about 0.4 seconds. Now that's what we need. If any of y'all are into the web performance stuff and you go to Steve Suter's talks, right? What do we know? We know a web page has to load in less than 2 seconds end to end, right? And I mean, that's a long time, and you need to see stuff on the screen a lot more quickly than that. Well, with these kind of formats, we can do it. And this isn't, of course, just a movie. I can switch the cameras here, right? And so this came from 3D Studio Max. It was converted to Collada, exported to Collada, and then we ran a converter on it that Fabrice is going to speak later, has written, which takes the Collada and turns it into GLTF, nice and compact. So that pipeline is starting to come. So all the professional tools, 3D Studio Max, Maya, Blender, SketchUp, they will be able to support this kind of experience. Let's see if I can just go out to the free camera for a second here. You can see our little virtual city in its full glory. So there we go. So help's coming on the pipeline. Well, we talked about this earlier. Where does it run? Well, it runs pretty much everywhere. I did mention a little bump in the road with iOS. For whatever reason, Apple has not turned on WebGL support inside mobile Safari. However, they do have it running in a limited fashion in their iAds platform. So if you make an iAd to be inserted into someone's freemium game or whatever, you've got full HTML5 that you can use to build the iAd and includes WebGL. But that's kind of limited. It'd be really nice if you could hit any website with mobile Safari and the WebGL would just work. And it's a little frustrating that it hasn't happened yet. Tim Cook, if you're listening, let's talk. I'll even come down to Cupertino. I don't mind driving down there. So hopefully that will be fixed at some point. It's not yet. But the good news is there are solutions today that will let you take your HTML5 app, because I know people here in this group especially are interested in building their stuff once in HTML5 and then getting it to run everywhere. You can take your HTML5 app and sort of a la PhoneGap, there are adapter technologies for making the whole thing run inside Android and iOS platforms that don't support WebGL yet. Android, less of an issue now because most of the Android devices actually do it. And one I'm talking about here is Cocoon.js. The Cocoon folks in the room somewhere, I know they're kicking around. It's a company called Ludai. They are in San Francisco, and they make a technology that basically implements the WebGL API and a couple of other APIs that aren't built into iOS or easy to use in iOS, and they give you some tools for making that all easy. And basically, with very little change to your code, you can adapt that and bring it into iOS and make an app. They'll even make the app for you. Hey, you're not an iOS coder? They'll build it. They got a cloud service doing it for you. All you have to do is sign it with your developer ID and submit it to the store. So that's really great, and I encourage you to go look at that. So, getting really close here. So my opinion, and this is why I'm so happy we're here tonight, and Peter, thank you again, and Don Olmsted, thank you for suggesting I come here and talk tonight. I think we're getting to a tipping point. A year ago, Microsoft, WebGL, I don't know, security, whatever, blah, blah, blah. Well, they changed their tune, and they're really supporting WebGL pretty well. I went into Best Buy. I went up to a laptop. I hit a URL I knew was a WebGL URL with Internet Explorer. I didn't go sneakily download Chrome like I usually do on every machine I go to at Best Buy. I just went and hit it, and it worked. I hit that 100,000 stars. I hit that car. All those things I showed you, they all just worked. So that's great. I mentioned the Kindle Fire HDX. I don't know if we're going to get this on camera, but let's see here. Come on. Yeah, here we go. So here's a little interactive piece I built for my book. I don't know if you can see it from here. Cars spinning around. I took this untouched. It just worked out of the box. This thing I built in HTML5 and WebGL. And then I added touch events so I can zoom and touch on different pieces of the model. That took me half a day to add the touch support. Good to go. Running at 60 frames a second. This thing screams. Amazing. Yeah, so 7-inch, great deal. Go get one. And then we have another speaker tonight, Don Olmsted, who I just mentioned. He works at Sony. You know what he did? He built the entire PS4 interface in WebGL. So there we go. 4+ million seats in one whack, WebGL powered. God bless you. The people who track sort of browser stats, this is a good one. You know that NORAD website that tracks Santa's progress around the globe every year? So they've had a WebGL thing for the last couple of years, and we saw 146% increase in people who got into the 3D experience, which meant their browser actually supported WebGL, mostly was the issue, right? I mentioned this. Opera is now powering a Bang & Olufsen TV with their devices SDK, so we're going to have smart TVs with full HTML5 in them. And tonight's event, I think we broke all the records, right? So WebGL definitely about to tip the scales, and I'm personally delighted, and I think this is really exciting. I mean, people's enthusiasm for this has been just incredible, this event tonight. So I encourage you to stay in touch. All my particulars are here. Like I said, the slideshow is going to be up on SlideShare for you, so all the URLs will be there. And I was just talking to Vanessa, and I think what I'm going to do is ask O'Reilly to get me a promo code so anybody from this meetup tonight can get a free version of the new book as an ebook. The print one you got to pay for, and I'll sign it, I promise. So we'll make sure that we get you the new book. But if you go on Amazon, search for my name, you'll see these 2 titles up there. And with that, thank you again, Peter, and go forth. Oh, thank you very much. I will treasure it.
All right.
Yeah, hang on.
Just switching laptops here for a second. Great. The next speaker was already introduced by Tony, so did my work for me. So Don is here. He's a senior software engineer at Sony. Has worked on the PS4 front end, and that's using WebGL, and he'll tell you a lot more about it, I'm sure. So do you want to go put your, okay, good, just 1 second. So while we're at it, HTML5, SFHTML5 hashtag when you're tweeting about the events. The other thing I would like to ask everyone, we often don't get a lot of feedback, like on the day after you probably get an email asking you to give it some rating or any comments. We really appreciate these comments. We read every one of them. Like the survey that we did, we went through every single piece of feedback. So appreciate you giving some feedback. Just keep it very simple, a couple of stars and whatever feedback you want to give. So yeah, so we had a small issue with the audio again in the room. We're in the process of fixing that. Hopefully everyone will be able to hear it loud and clear. Again, this URL that you're watching this live stream on is actually also going to be the URL for the recording. So all of the Google Developers Live sessions, they're always at the specific YouTube URL, and then immediately after the event, they're available. So if you missed it, you can always catch it there. All right.
I think we might have some fiddling to do on their end.
Just a moment here. We're going to have questions at the end of the event with all the speakers. So we have a Q&A panel with everyone in one shot. So
We're good?
I think we're good.
All right.
Thank you, Don.
Thank you.
All right.
All right. So, as Tony mentioned, my name is Don Olmstead. I work over at Sony Network Entertainment, and I wrote the WebGL layer for the PS4. So, obviously, thank you all for coming, and really, it's been an amazing response with everything, and definitely excited to be here. So, Tony gave sort of the grand overview of what is WebGL. The next speakers are probably going to give a bunch of fun, cool demos. And I am here to blind you with computer science. So I'm definitely not going to give you any fun whiz-bang demos or anything like that. But afterwards, you're going to have a much better understanding on how WebGL actually works under the hood. And the reality is that, yeah, you might be using a framework like 3 or any other of the many frameworks, but there's a good chance that if you're really, really pushing the hardware, eventually you're going to outgrow it. And then you're going to need to come down to my level here. So I wanted to start off with pretty much what I did for the PS4 and some of the choices we made here. So let's talk about the PS4. We released in November. The same day this meetup was announced. And actually, we sold 1 million units in a single day. And sales continued to be pretty good, 4.2 million in 2013. And obviously, the best part is that every time you log in, you are running WebGL code. So why did we end up using WebGL? Well, to be honest, it was really more or less a pragmatic decision. So here I'm going to talk a little bit about the architecture of the PlayStation Store, which is what our team works on. So we really wanted the same code to run on multiple platforms. And obviously, the most important avenue for this is PlayStation hardware itself. So this is the PS3 and the PS4. But we also wanted to support people working in the browser. And this is just to make devs' lives easier in case they were away from their hardware. And really, that's where the WebGL usage started. So actually, most of our devs use Chrome, and if you went to our booth outside, you could actually see the PlayStation Store running in Chrome. And yeah, that was more or less what we had. So in this case, I want to start by giving more of an overview of what it is we actually have. What does our software stack look like? So in the case of the PS3, the bottom is actually Fire Engine. And Fire Engine is a game engine provided by Sony for all licensees. And actually, it powered Journey. So same set of code there. On top of that, we had an API layer we called Trilithium. So this is actually a JavaScript API for drawing a 2D scene. I was not involved in the naming. So actually, this is all bound to a JavaScript VM. And it allowed our programmers to create this UI layer, which is more or less a homegrown immediate mode GUI made to look DOM-ish. And on top of that, our devs ran and made the PlayStation Store. So let's talk about the PS4. So obviously, we had a large code base. We needed compatibility with the PS3. We also wanted some more web features, and we didn't have time to rewrite the whole thing. So we actually have a working port of WebKit that powers our browser. This is more or less where I normally work on the rendering side there. And to actually do the port, what we needed to do was recreate that Trilithium layer, but in WebGL. So that meant for us, our UI framework didn't have to change, and neither did the store. So we had a problem. We had reached a point where launch was looming in front of us, and basically the performance was not there. And really the user experience was suffering because of it. So we started investigating the issue, and my assertion was it's JavaScript's fault. So for me, sort of the avenue to go would be to attack that bottom Trilithium layer and fix it, essentially. So I started optimizing this layer. I really wasn't getting the performance gains I actually wanted and what I thought was actually possible. So we're really close to launch. Performance isn't there. So what do? Well, as any seasoned developer knows, you burn everything to the ground. And in its place, create something awesome. So, really I only recommend that as a last resort. And I more or less went down this route because I was already touching a good amount of the code. And I really wanted to open up all the optimizations that really I'm here to talk to you about. So with the intro, let's begin. So what do you need to know? Well, first off, if you're actually trying to figure out what's going on with your WebGL application, you want to profile. So you need to profile and figure out exactly where your app is spending its time. And if rendering turns out to be your problem, and you're using WebGL, you really need to understand two things. So that's how does WebGL slot into the browser? And you need to know how WebGL works so you can optimize your interaction with the API. So then you kind of walk further up the stack. You need to start thinking about how you're submitting geometry. And of course, you need to ensure that work is being done completely in the animation loop itself. All right. So first off, let's talk about an animation frame. So you basically have 16.6 milliseconds to do all your work. And honestly, it's safer if you finish quite a bit before then. So if you finish in the allotted time, you'll get, of course, the silky smooth 60 FPS, the holy grail of all graphics programming. And if you don't do it, you're going to drop a frame. And if you do it enough, your user experience will definitely suffer. The animations themselves will look jerky, the controls will seem laggy, it's not good, and this was more or less the state we were in beforehand. So the other thing to remember is on top of that, the browser is doing plenty of other things that can further limit your frame time. So the big one, of course, is the waste monster, also known as the garbage collector. And you have to remember, it can trigger at any time and take as much time as it wants. It doesn't care. So you also need to know that other browser events are going to happen outside of the animation frame. And this is something we're going to come and circle back to later on. So when you're profiling, we need to look at what happens during a frame. And we use a profiler. There are actually two types available to the web dev, in Chrome specifically. So you have that sampling profiler, and this will essentially take little snapshots to try and determine where the time is being spent within your app. And that's essentially what you find in the Chrome developer tools. So something that's a bit more advanced is a structural profiler. So in this case, you're actually inserting code into your code to figure out where your time's being spent. And this is something you'll find if you use Chrome tracing, and you'll basically litter your code with console time end. But there's an even better solution, which is the web tracing framework. Now, unfortunately, the web tracing framework came out a little bit after when I would have really liked it. But it's a solution from Google, and obviously one of the programmers is a smartass because WTF. So, you have your structural profiler. What do you do? Where do you begin? So really, you want to kind of place markers at various points of interest in your code. For a graphics application, typically there's an update, and then there's a render. So these are the sort of things where you want to place the markers and then sort of continue deep diving further and further. And from there, you'll be able to figure out what exactly is going on. So here's a little slide with what the web tracing framework will give you. If you kind of look here, obviously really hard to tell, but over on this side is the update. Over on this side is the render. So this particular trace, it was from an example game on their homepage. And you can kind of see how this is a lot of information. And if you're familiar with Chrome tracing, you'll see it's presented in a much nicer way. With Chrome tracing, you get everything, which is a bit harder to kind of drill down into. So I definitely recommend playing with it on your own, and it also does some other fun things like the garbage collection. So it will actually tell you where the garbage collection is happening. So let's say we ran our application and we were seeing a good amount of time in the render portion. So what do we do? It's really important to know what's going on under the hood. So in this case, I'm going to talk about Blink. I'm going to talk about Blink because WebKit is way more convoluted than Blink. So in our app, we're going to make a WebGL call. So we're in our JavaScript code. And from there, the call goes into the V8 WebGL rendering context. So basically, any of the browser APIs that end up getting exposed to the application, they tend to be auto-generated. And there's actually an interface definition language that generates all this. So this is the same thing with the WebGL bits. So from there, we're going to end up in the WebGL rendering context. And at this point, we're going to handle any sort of validation and any sort of security checks. So after that, we can take a detour to the context support class. The naming's not there. Actually, Brandon Jones, one of the Chrome GPU developers, was telling me, no, your diagram's wrong. Here's how it is now. So there is some sort of context support class that will essentially do stuff like loading a texture. But really where it's going to end up is the web graphics context. So the thing to remember is that WebGL is not the only thing running in the browser. So there are certain conditions that will cause your web page to be promoted to the GPU. And web devs typically do this with a translation of 0. So any of that, they're kind of hoping it's going to promote it to the graphics card, and hopefully it's faster. Now that web graphics context, what it does is it fills a command buffer, and that command buffer ends up getting picked up by the GPU process. So obviously there's a lot of code, and this is more or less the 1,000-foot view. But this kind of gives you an idea on what happens every time you make a call into WebGL. So what's the takeaway? Well, every time you call into WebGL, there's always going to be some amount of overhead, and you're not going to be able to avoid it. It's there completely by design to ensure security, as well as support other things the browser is actually doing. So what this means is there's a hard limit to the number of calls that can happen in a frame. Now the exact number is really going to vary on the hardware, but because of this, we need to make sure we are making the smallest possible number of calls to WebGL. So how do we know what calls should actually occur? Well, WebGL itself is a state machine. So what that means is that whenever you make a call, when you make a WebGL call, you are very likely to be changing state. There's some calls that won't change state, but the good chunk of them, if you're actually doing any work, are going to modify some form of state. So this could be multiple things. So you can affect the entirety of the rendering context. So you can do something like change the depth test you're using, and that's going to be when you change it, it's there, and that's what's happening. You can also change the state of a WebGL object. A WebGL object is basically anything you would make through a create function. So this includes stuff like textures, your shader programs, and your buffers. So if a call that should change state does not actually change any state after execution, this is known as a redundant call. So in this case, I'm going to give you an example. So on the left, we have just a simple batch of code. It's just going to be interacting with the program, saying some uniforms, and then it's off on its way. On the right, I'm giving kind of a diagram on what's happening in the totality of the rendering context, as well as what's happening with the individual program itself. So if we step through this function, first off, we hit GL use program. So this is going to bind the program to the pipeline. You're now rendering with that particular program. You're going to call and modify the uniform. Now in this case, we are taking the alpha within this shader, and we're setting it to 0.5. That's cool because we were at 0 before. Now we go ahead and take that, we modify the texture unit a sampler is referring to, and we're setting it to 0. Well, the thing is, it was already 0, and essentially this call did nothing. And of course, if you're doing this, you are paying the price for it, as it's a redundant call. So how do we stop this? Well, this actually requires some brains in the application. Basically, if you are writing a renderer for WebGL, you basically need to mirror the entire state of WebGL within your application. So whenever a call is made, essentially we need to compare this, the current value to the value we want to set it to. And if it's not equal, we can go ahead and let the call slide through. If it is equal, we want to stop it in its tracks. And like I said, the renderer needs to be designed to handle this for every single instance of WebGL call to be optimal. So in this example, I grabbed some of the code from the Trilithium API. And this is one of those cases where we are limiting the number of calls. And this is just a simple functor. It has a current state. When you try and set the value, it compares it to the current value within the functor. And like I said, if it's different, we go ahead and make the call. If it's the same, we ignore it completely. So really, this was a big win for us. The older version of the API did nothing like this. So it drastically cut down the number of calls. And here are some results for you. So at best, we are making a quarter of the number of calls. That meant that in some cases, 3/4 of the number of calls were worthless. And at worst, we seem to be making about half the number of calls we made. And my completely unscientific study of it seemed to say that it was about 1/3 on average. And really, at this point in time, everything started feeling a lot better. It was a lot less scary that I burned everything down. And people were quite a bit more receptive at this point. So with our optimized renderer in place, we need to go higher. Remember, you can still get yourself in trouble if you aren't submitting your geometry in an optimal way. So here are some general rules you should be following. If you can't see it, don't draw it. Basically, you want to compare the geometry to the camera. If the camera can see it, go ahead and let it through. If it can't, stop it in its tracks. We also want to submit any opaque geometry front to back. Now, the rationale here is if you have a large geometry and it's fairly close to you, but there's another geometry behind it, if you draw that one first, the depth test for that second geometry is likely a fail. And if you have a fragment shader that's taking up a good amount of time, that can save you some work, and it's definitely optimization you should try for. But also remember, on the converse, the opposite is true for your transparent geometry. You want to render them the opposite way. Otherwise, your blending will not look correct. And of course, what you want to do is also to try to group geometry with the same state. And this is to minimize the amount of calls we're going into WebGL. Of course, the most important rule of optimization, optimize for your case, not the general case. You really need to think about how your scene works, you need to figure out your requirements, and you need to design your algorithm around this. And that's how you will really be able to push the hardware in new and interesting ways. So in this case, what did the PlayStation Store's scene look like? Well, the tree was pretty deep. We had a lot of nodes that were basically used to position other nodes. And the worst case I saw was a tree with 26 levels. It was a ton of nodes, not a lot of actual drawable entities. The other thing to remember in the PlayStation Store was our textures were unique. So we would constantly be requesting product images, text, and that didn't really allow us to do sheeting. Texture sheeting is a technique you would use to limit the number of times you switch a texture. CSS can also do something like this, and definitely the perf guys will tell you to do this. So another thing that was characteristic of our scene was the objects themselves weren't too mobile. So that means that really the only time stuff would start moving is when you had user input. And we also had a requirement that some areas needed to be clipped to some bounding area. So with that in mind, what did we do? So since things weren't moving that much, the visible set was only computed when the tree changed. So the visible set meaning we run through our tree, we figure out what is actually available to draw, and we use that to feed the renderer. The scene was deep, so rather than bubbling up the bounding volumes, which is what you'll see in a lot of engines, where the bounding volume of the object below kind of affects the one up higher, and we bubble up, 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 all the way to the top. So this didn't really help us, and it would have created a hell of a lot more work because, as I said, a lot of the things had to do with positioning. And in our case, whenever we use those bounding volumes as the actual points of clipping. And when the intersected bounding volume was met, what we would do is intersect those and use that smaller bounding volume to affect the geometry further down the tree. So let me give you an example of that. So let's say that in the case of the yellowish nodes, those actually have clipping volumes associated with them. So we kind of work our way down the left, and we compare those two clipping volumes. We do an intersection. They do intersect. So then we use that smaller volume to compare the leaf node. In this case, it passes, so it's added to the visible set. So then we're going to continue down over on this side, and we just compare it with that top one, and we find it's within our view, so it goes through. Now we go further down into the right side, so we're comparing these two and seeing the intersection. So there is actually no intersection, so at that point we can say, all right, we're not even going to bother with the rest of you guys. So that's more or less how the algorithm worked in our case. So the last tip for you is to keep your work within the animation frame. So as I mentioned, the browser has a ton of other things going on. It does not think you're that important. So there are things that are going to happen outside your frame. And the big one there would obviously be timeouts. And it also includes getting your images, getting your HTTP requests. And of course, remember, if there's an event or series of events that take up a good amount of your time, you can completely drop a frame, and you will be looking at your frame and say, well, I was ready in 5 milliseconds. I don't know what happened. Well, most likely a timeout of some kind happened. So to kind of combat this, we looked at how resources were actually being created within the store. So anytime a user ended up in a new view, there were a ton of requests going out. So we were requesting information on how things are laid out, images, getting text, all those things. And yeah, so a ton of texture, ton of product art, and we also had our text. So to keep the frame rate steady, we decided to basically pay off the amount of time over a series of frames. So to do this, we created a task manager, because why not have an operating system construct in your WebGL program? So it's not really complicated. It's just a simple FIFO, didn't go priority, wasn't really needed. So in our case, what exactly is a task for us? So when image is received, we actually defer the loading to the animation frame. So we get the response. We say, OK, you are a task. I am going to insert you to the queue, and you are going to run at some time in the future. So we also did text creation that way. Our text creation could probably be a bit better. There's certainly some optimizations we could do there, like a bitmap font or things like that. But due to the amount of time of me going nuclear, didn't really have time for that. So we actually use Canvas. And whenever we request a new batch of text, it actually busts it up into 3 steps. So initially, we compute the layout. From there, we take that and draw it into the canvas. And then another task comes around and actually uploads the canvas to a texture. Those last 2 end up being slotted right next to each other, so didn't really have to worry about anything in there. So to keep our frame rate steady, we needed to limit the amount of time we actually took to run these tasks. So that pretty much ensures the application has enough time for anything else it wants to do, like an update and render and all that. So obviously it's not a perfect solution because there's essentially no way to stop a task once it's started. When you upload a texture, it's going to take however long it's going to take, and that's it. So if you had the case where you set something for, let's say, 5 milliseconds, and you had your task finish at 4, it's going to kick off another one. And if that one goes another 5 milliseconds, really not much you can do. So really at this point to do that, we more or less kind of played with the numbers and figure out exactly what felt good in terms of the frame rate versus how quickly the assets were appearing. So if you made it super quick, you're always going to get 60, but things are going to kind of creep in slower. So it's definitely a balancing game there. So, obviously our task manager, nothing special. First in, first out. We look at the number of tasks. We compare it to whatever our maximum time span is. We pop a task, we run it, we check it, and we keep going until we either run out of tasks or we run out of time. So like I said, nothing special, but it actually really helped us kind of keep that frame rate. So in conclusion here, if you want to optimize a WebGL application, you need to do the following. You need to ensure your renderer is optimal by preventing redundant calls. You need to optimize how geometry is submitted to your application. And really, to avoid any sort of jank, you need to keep the work on the animation frame. So if you follow these rules, you'll be able to really push your application even further and create even more compelling, awesome experiences with WebGL. So now we are in the shameless self-promotion portion of the talk. So this particular talk is more or less a PS4 themed version of an article I wrote for HTML5 Game Development Insights. It's currently available for pre-order on Apress, and it has a lot of great input from other devs, and the pirate guy helped out, who I'm sure you've seen.
Oh, kill your crew.
Yes, kill your crew. All right, so any questions? We're deferring to the QA panel, but here's obviously my contact info on the right. I'm pretty good with G+. I also go to various other speaking gigs, like speaking at the Dart SF meetup next month, because Dart is awesome. And of course, SNEI is hiring. We have a booth here. We have a PlayStation 4. And obviously, if you're a web dev, one of the things that really sucks about web dev is worrying about older browsers. And we don't really have that since we own the browser. So, you're not really going to have to worry about IE 8 or anything like that. So definitely thank you guys for having me. All right.
Thank you, Don. Get our speaker gift. Great. Well, so it's time to take a break. For those of you who've been listening in the overflow room next door, sorry we had a couple of issues. We keep trying to tweak the sound, and during this next break we'll take another shot at that. So we're going to take a break. If you're on deck for one of the lightning talks, we don't we don't have space for more, but we'll start at well in 30 minutes with a 3 or 4 lightning talks. If you're on that list, you would know, and then come and see us in about 20 minutes over here. So we have some more wine. We don't want to take it home. Also, we have some dessert out and some more music. So enjoy and come back here. All right, great. So we've got a couple of quick lightning talks before we get into the next talk from Peter and Victor. So the first one, Tyson, telling us a little bit about Mission Bit.
Peter, thanks for inviting me up here, and so nice to see so many Hack Reactor tribesmen. Cheers. Mission Bit is a. Mission Bit, is that good? Like this? Mission Bit is a nonprofit that's focused on offering free computer programming classes to San Francisco public school kids. Really, there's kind of two problems that we're trying to address. One is that Bay Area companies have thousands of unfilled jobs due to skill mismatch problems. And on the other side, only 30%, 5 of 17 public high schools in San Francisco actually offer any sort of computer science program. And so as our goals in trying to tackle that problem are really to create net new coders, so more kids learn how to code, teaching them to code at an earlier age, accelerating their pace of learning, and then tying that learning, basically through that learning, empowering them with skills and approaches that they would be expected to have when they enter the workforce. So we started last semester. I mean, it's really a grassroots organization in the sense that it's ground up. Everybody's volunteering their time, and we get donations of laptops for in-class instruction. The lead instructors are volunteering their time. The assistant instructors are volunteering their time. We started last semester, 19 kids from six different school districts, or 6 different schools. 43% of the class was women. 90% of them had never written a line of code. The group projects that they were working on by the end of the semester were an HTML5 multi-level game, a chat app. This semester we're growing 300%, and we're doing 2 high school level classes, intro, one at Mission High, another one out at Balboa. A middle school program that we started yesterday at James Lick, and then an intermediate class. And for the summer, we already have a couple of paid internships, summer internships with that will be programming based at Hack Reactor. And then we're doing a mock product group where in the summer we will take 15 kids and run through what it's like to develop a product end to end, and then possibly commercialize it if it gets a green light from the organization sponsoring that. I could show you a video if you want to see like some interviews of the kids, but I mean, there's a couple of ways that this crowd can participate. One is we're always looking for awesome engineers to volunteer their time. If you're interested in volunteering as an instructor in the class or in one of the classes, you can go to Mission Bit, and there's a way that you can sign up to be an instructor there. If there's people here representing different companies, we're always looking for opportunities to bridge the kids with industry opportunities. And if you have any rich uncles or aunts that want to donate, we launched a crowdfunding campaign yesterday or 2 days ago. But thanks for your support, and it's an awesome movement. I just want to leave you with one anecdote from one of the kids from the fall class. It was a kid. He's awesome. He thought he had resigned himself to being. He wanted to be in the games industry, and he resigned himself to being kind of an artist on a games team. And after taking the Mission Bit class, his comment was, "I love math. I used to hate it. Now I know why it has purpose." And
all right. Thanks, Tyson. All right, next up we have Eric. We'll do next, talking a little bit about a WebGL experiment that he's done. No, this one. Oh, right, you're the mic.
Icicle's going to hold the mic for me. Hey, everyone. I'm Eric. I'm a front-end developer here in the city. And I've been playing a lot around with WebGL. And right now I'm making a 3D art game. So basically, you have different particle effects. You can fly and create all kinds of different stuff. I don't know where the volume is. There we go. Yeah. So you can switch to different effects like fire. Create fire. You can create flying jellyfish, fly up above, and create some fireflies, and create like a little firefly garden, stuff like that. So basically, I want to make it networked, and I want to get a lot of other people involved. All these little caves can have different little experiments in them. So if you fly over to this one here, see a little Ferris wheel going on. So it's up on GitHub. My email is aricrius1@gmail.com. So if anyone's interested in joining in, send me an email. And I use 3JS, and I love this community. It's so awesome. I'd never done 3D programming before, and there's so many awesome libraries, and it's just such an amazing learning experience. So yeah, it's an awesome thing. So join this game. Thanks, everyone.
Thank you. All right, and our final lightning talk for now is Matt. There you go.
Yeah. Hi, I'm Matt Tyndall, founder and CEO of Tinge, and we're doing stuff with rating and recommendations. And this is something I built for a hackathon last month, and we're building this out. It's a 2D rating system. So the idea is that you can rate how you feel about something over time. So let's say you just watched a movie or TV show. This here is a movie trailer. And so you can say, oh, it was awesome. And then this part sucked, that was boring. But this part was awesome. Explosions. So the idea is that this works on touch. This is using HTML5 canvas. And this is for capturing anything where your opinion changes over time. So on a mobile device, you can do this really easily, just with your thumb. And it can be used to, for instance, rate an event if you want to get feedback really quickly, or project how something went. Or, for instance, on a TV show, like if you want to know how many episodes in before something gets good, if you should pick a new series on Netflix. And also, just because this is I hacked the famous demos they put out to, like, you could these are rendering a whole bunch of different ones. So you can imagine these would be a bunch of different episodes. So you can really see how these things, people's opinions add up over time and get more context. So, yeah, so this is just the famous UI. So yeah, if you're interested, so we're going to be starting a private beta doing some stuff with this. Reach out to me at matt@tinj.com. Thanks.
All right. That was pretty cool. Thank you. All right. So next talk, it's actually a talk with two speakers. So we have Victor Sand from all the way from Sweden, right? And he works at Goo. And the other speaker will be Peter Moskowitz from Kazing. Already talked to you. All right. Over to you.
Thank you. Thank you. All right. Let's see where we left off here.
HTML5 is the hashtag.
Let me help him.
Did we just turn this? Where do we put it?
Yeah, let me.
Computers. Sponsors. Good. Ah, there we go.
Is this what you need?
Yeah, that's perfect. Thank you. All right. Hi, everyone. I'm Victor. Thanks for having us here. Thanks to SFHTML5 for arranging this wonderful meetup. I work for Goo Technologies, based in Stockholm, Sweden. And with me today, as Peter said, is another Peter from Kazing, based here in California. And as a colleague of mine put it, WebGL is very good at solving a very specific computer science problem of today. And that problem is to get the highest amount of likes per line of code. The measurement to keep track of the next few years will be LPL, the likes per line. And we've seen, as we've seen in the previous talks, that, for example, Chrome experiments, collecting a lot of really cool hacks of WebGL wizardry and WebGL examples from people that know this really well. But the question now is, how do we get this into more hands? How do we get WebGL into the hands of all the creators that are out there? And this, of course, can be graphics wizards and game developers and hackers, but it can also be artists, architects, teachers, advertisers, interface designers, and so on. How do we give them the power of WebGL? And the answer to that question is we build pipelines and we design workflows. Because not everyone dreams about spending all their Friday nights with shader debugging. I know it's really hard to imagine those people exist, but they do. So the first step, as we've already seen also, is to get a 3D engine going. It takes care of all the low-level WebGL stuff that we don't want to do every time. It gives us a nice API to play with. And one thing that I think is very important when we do this is that we try to use open web standards as much as possible. In this case, it means nothing but JavaScript, HTML5, and of course WebGL. Because what happens then is that a lot of people know JavaScript. And suddenly they now have tools to also kind of know 3D. And it also means that you don't have any plugins or any downloads necessary to share your work later. So I want to show you some more demos. So that's kind of why we're here, right? So this first demo can show you that not only can you render cool 3D stuff, you can also integrate other things in this, like, for example, video, like in this case, once you decide to use all these open standards. The other demo I want to show is this one. It's something that we've, let's see, so many sliders. I need more resolution, Peter. Where's the resolution? Oh, there we go. Now we see the slider, and I can click that one. Sorry about that. There we go. This is a demo of pretty much a full-fledged flight simulator of a really old Swedish fighter plane. Those exist. Actually, it's a thing. I did not make that up. This screencast is running in is recorded in Chrome, and it's something that we have developed internally while we are building our GU engine. Because it turns out it's not easy to build a pipeline, and it's really hard to define a workflow, and you need people to kind of tell you how they want it to be done. So this is what can be done, of course, and it's really useful to have people in-house to do that kind of stuff. Let's close that. So that's great. Now if we have a couple of different 3D engines in open web standards that we can use, but what do we do about the people that don't want to code or don't know how to code? Well, the answer is, again, we build a pipeline. We build more things. We build a pipeline that can handle things. So if you have a model of a really old Swedish fighter plane and you want to get this online, you need a way to do that. And you need a way to do things with it visually without necessarily writing code all the time to move things around. And then, of course, you want to be able to share it with as many users as possible to get as many likes as possible. That's the whole point. So I'd like to show you a tool that does try to solve part of this puzzle. And this tool we call GU Create. Looks like this. And this part here to the right is the 3D canvas where the 3D engine will put all the stuff and render that. The interface that you can see to the left here is built using a very, very, very large amount of Angular. And behind all this, there's a Python backend running. And the backend takes care of exporting and importing models into a format that the engine understands. But it also fills the very important part of managing users and projects. Because in a pipeline, of course, you want a place to do your things. You want one place to store all your work. So the way this works is, say that you have a 3D model that someone built. In this case, saved in an Collada, kind of large FBX file format. And what you can do here is you simply, if you can get all the windows to see at the same time, you can drag and drop this onto the canvas. And once the backend has converted this to a model, a format that the engine understands, we can start to interact with it. So there we go. Now we have this 3D model here, and I can start interacting with it. Looks kind of creepy right now, but luckily the designers thought of that and put some materials and textures onto this. So clothing, for example, what we can do here now is do some more dragging and dropping, because I happen to have textures in a standard PNG format here. So this was the clothing. So let's just actually see if we can see what happens here. Drag and drop that onto the model, and then we can do the same thing for the hair. There we go. and for the skin as well. There we go, and that looks a little better, right? And this interface lets us interact with it and add things like sounds and cameras and lights and so on. And this model happens to have an animation. So if I press play here, we can watch it and see it in real time without writing any code. So let's try to add a light, for example, and see what happens. Add a light here, and we can start moving that around, set some parameters, and see the scene change in real time, fully interactively. It's all in the browser. It's not using any plugins or any downloads like that. And let's go to my favorite panel, and it's the post effects panel. It's very good for likes, very good for likes. So if we want to add some glow to this, okay, that's a bit much. Maybe we'll tone it down a little bit. Or some grain. We can add some movie vignetting, etc., etc. You get the point. And once we're done with the scene now, thanks to that we have all these awesome web standards to play with, we can share our work very easily by just basically clicking a button, bundling everything up together, including the engine and the data format, and push this to a website. And now if you have a decent WebGL compatible browser on your tablet or your phone or your computer, on your refrigerator or your washing machine, you can surf into this website and look at this right now, actually. I'll give you a tiny URL version of this in a minute. And of course, if you want to code, you can do that as well. You can export this into a JavaScript template and add your own code and then keep working on that, because we like to code, right? Now, so if you want to try this out, you can do that. You can go to that tiny URL and you'll see the same link. Or you can sign up for the beta. It's free right now if you want to try the tool out. So what happens now? What's next? Now we have all these things. I can take my Swedish fighter jet model and put it on the internet, but we need to think about what happens in the future. And I want to talk a little bit about the funnel. It's a kind of a pipeline, right? You take a lot of input, and you get a very defined one kind of output. So here's my invention. It's the double funnel. Probably the worst invention ever made, if you would ever use it in real life. It's really hard to get venture capital for it, but if you want to talk later, we can do that. But it illustrates the point here. We want to take a wide array of inputs from different people in different formats for different purposes, use the tools that we have, and then push it out to different distribution channels, cooperation ways. We want to push this to games, to apps, to programs, whatever, you name it. So, the double funnel. It's the future, promise. And demo time again, of course. We like demos. I want to show you a little bit more complete product built on this Go engine. This is the same guy that we saw earlier, and this one I can make him roll around here by pressing standard keyboard control. I can turn him around and so forth. It's all done interactively in real time. And I mean, a mouse and a keyboard is fine, but if we want to kick it up a few notches, Peter, what do we do then?
Microphone. Yes, excellent. Thank you. Great. Thank you, Victor. This is awesome. So what we have seen is that you can add extra layers and tooling on top of WebGL, and by doing so, you can make it accessible to those who are not necessarily coding. So what I wanted to discuss a little bit is how we can use related HTML5 technologies to improve the WebGL experience. Specifically, the area that we are focusing on, and I've been focusing on in the last couple of years, is real-time web communications and how you can improve this experience. So what I've done here is I pulled up a remote control on my browser. The remote control on my phone is running in Safari without having installed anything. I have a URL that I went to. And by simply tapping the buttons here on my phone, I am sending messages to the application that's running here on the desktop. So what is happening here behind the scene? My phone is on the AT&T LTE network, and it has a means to send very low latency, very small messages to my PC over here. So let's take a very quick look at how we can achieve this kind of experience. Let me do a little bit of dancing here. So I have my desktop app pulled up. That is a web browser on the top. And on the bottom, we see my Safari browser. Both of these HTML5 apps are connecting to a WebSocket server. The WebSocket server has the ability to receive and send messages. So very much like, thank you, very much like in the world of HTTP, you do need a WebSocket server for WebSocket communication. The fundamental difference between the REST-based world and the WebSocket-based world is that you have the ability to keep this connection open between your client and the server and send these messages with extreme low overhead back and forth between the server. So my desktop application is not sitting there and polling the server, is there a new message for me? Is there a new message for me? It's just sitting there idle. And whenever I press a button here on my phone, the WebSocket server passes that message to the application, and let me close this. And it allows us to navigate on the screen. So a few words about this communication technique. Originally, it was designed to bring the same power to web applications that we have in the world of any connected application in the TCP world. So now you can say that whatever app there is out there, whatever connected app is out there in the world of TCP, now we can do that over the web. And this gives us an incredible power to improve our WebGL and non-WebGL applications. So we have this permanent connection and allows us to build these event-driven applications, which is a major shift from having REST-oriented request-response kinds of applications where the client is requesting information from the server. Now you have the ability to send these messages freely back and forth. When you are building a networked application, you are not going against a low-level network API or the protocol. You are building an email application or a chat application, there's a good chance that you are using something like IMAP or SMTP for email or XMPP Jabber for your email client. WebSocket, as the standard, was designed to support these higher-level, richer protocols. So in our case, you can build very easy PubSub experiences, PubSub APIs, that allow you to build these apps very quickly and very easily. Not only that, WebSocket was not designed to be there exclusively for web browsers. It was designed to be agnostic to the client. So you can build native mobile applications. You can build Android, iOS applications natively. Not only that, you can build desktop applications. You can have a .NET, a Flash, or a Java application that can have this kind of real-time communication all over, going all over the web. So again, remember, I had a browser-based app running here in my phone. I was connecting to the network over LTE. I pressed the button here, and that message was sent to the WebSocket server, and it bounced back here to my laptop. That WebSocket server that I was communicating with is in the East Coast of the US, 3,000 miles away from here. So it had to cross the continent back and forth to get this data here across. Okay. Now, I wanted to show an example how this can be elevated even further. Everybody brought their awesome 3D designs and awesome 3D models, and I decided to bring mine. So here I have my 3D model. Just look at the textures here. Look at the reflections on the design. It's pretty impressive. So what is this? We went out to Toys R Us, and we bought a radio-controlled truck. And after driving it around a little bit in the office, we said that maybe we can do it better. So we ripped out all the radio-controlled functionality, and we glued a credit card-sized little computer onto the back of the truck. And what this does is it has USB ports. You can attach a little Wi-Fi card. It has an Ethernet port. It has an SD card that you can put the operating system on. But most importantly, it has the ability to control external electronics. It has a notion of a general purpose input-output port that allows you to control, let's say, a car. You can kind of drive it around in our case. We have 3 pairs of these adapters, and I'm going to attempt to show that to you in a minute. Now, I could drive it around the same way I was trying to control, or I was controlling the Leap Boy on the screen, or the Pearl Boy on the screen. But my favorite way of showing this kind of demonstration is having somebody very far away, maybe continents away, Skyped in, and have that person control the truck. Now we have some network limitations here, and we couldn't achieve this, or couldn't quite do this, set up this networking. But I brought the experience to you, so I'm kind of doing these acrobatic tricks without the net underneath me. So we'll try to do this. So what is going to happen is I will bring up a page, and in this page we are going to do a video call. So in the top left corner you see me, and in the middle of the screen you see David, and David has this ability of sitting there very patiently and not moving at all while he's waiting to control the truck. Let's see if we can have a chat with David. Hey, David, can you hear us?
Hello. Can you hear me?
Yeah, we can hear you. Hey, are you online?
Oh, well, yeah, we're on a video call right now, so I think I'm online.
Yeah, that's a good point. Hey, we have a truck here that we could use.
A truck?
Yeah, a truck.
I thought we were going to be controlling a drone.
No, we had to cancel the drone project.
Oh, okay.
Can you help us with a truck?
Yeah, absolutely.
Okay, so what are you going to do?
So I have the controls pulled up over here on my phone.
Okay.
So if you hold up the truck on your end, I can actually turn on and off the lights. So on, off, on, off.
Very cool. Can you turn the front wheels left and right?
Yeah, absolutely. So right, left, right, left.
Very cool. Can you spin the wheels a little bit?
Yeah, so forward, reverse, and forward, reverse.
Very cool. I'm going to put it down on the floor. Can you control it there a little bit for us?
Sure, let me know when you're ready.
Okay, we are ready, but be gentle. Very cool. Awesome. Thank you, David.
Oh, you're welcome.
Very nice.
So next time, remember to bring the drone.
We will bring the drone for you. Don't worry about that.
Bye.
Okay, take care. So, thank you. So what you have seen is magic. Basically what we did was we have a web browser running on a mobile device that can be on a carrier's network that has the ability to send real-time messages to any web application out there, or any WebSocket client for that matter. In our case, it's Java code running on the Raspberry Pi. If you're interested in how this experience was created here for you, you can just Google here in the bottom right corner. You Google for WebSocket and Popcorn. Popcorn is an awesome media library, and you can do these nice experiences with it. There's a blog post that we just put out. You can read all the details. Now, what do we do? What do I do when I am not here and having fun and meeting nice people at meetups? There are many, many challenges in the real-time web communication space that make it really hard and challenging to build and provide seamless experiences. There's the notion of firewalls and routers. Your connection gets broken down because you are in a tunnel. Maybe you need to scale out to millions of users because you become very successful suddenly. These are the kinds of problems that we are trying to solve, and we are very busy solving at Kazing. So if you want to learn more about Goo, how Goo enables web developers as well as creative people, here are a handful of links for you that you can go to. Goo is going to have, or is having actually, a beta program, and you're encouraged to sign up to those. And if you're interested in any of the real-time communication aspects, how you can bring this kind of power to your WebGL apps as well as to the physical world, you can visit the links on the Kazing site. And last, here's the contact information for us. Thank you very much.
Right, thank you.
Okay, we're switching to our next speaker. There he is. Let's have a picture. Thanks, Victor. All right. All right, so next up, we're going to switch the lights, dim the lights a little bit, I think. Do we need to? Okay. Yeah, okay. Come on up. Got some. Wow, wonderful here. All right. There's a lot of people. All right, while we're setting this up. So SFHTML5 is the hashtag you can use for tonight. We've got some great prizes, so hang on to those raffle tickets. We'll be doing a quick break after this, and then Q&A with all the speakers. We'll bring them all up, ask some questions, and then about 9:40 or so, we'll do the raffle, and then we need to be out of the building by 10. So that's going to get interesting. All right, so. All right, again, this event, it's on Google Developers Live. Check out developers.google.com/live/Chrome. Two things you will find there. The first one is our new Udacity office hours. So we just launched a course, Udacity Mobile Web Development. So if you're for a lot of you that will be quite relevant. So check out that course, and we're for the next 3 weeks, we'll be there every Tuesday morning at 9 Pacific, answering questions that you might ask. You can already ask them now for each of the units of the course, so definitely check that out. All of the talks, including these, are recorded, so bit.ly, SFHTML5 videos is where you can go to find all of the talks, so definitely check that out. Okay. So we need to dim the lights, right? Yeah. Okay. So can someone in the back of the room there dim the lights? Okay. You're good?
Okay.
All right. Let me just run over there and dim the lights.
Okay. Can everybody hear me? Yes. Okay, awesome. So first off, thanks so much to everybody who's put on tonight. It's been awesome. The DJ's killing it. Like everybody Googled, these places are amazing. If you haven't, I recommend you go try the bidet because those things are so crazy. Oh my God, life changer. Too much, yeah. Okay, so I think Elizabeth mentioned a few things at the beginning about what I do. I'm Isaac. I work as an experience engineer at Leap Motion, and so what that means to me is like somewhere between evangelicist and like reckless creator or something like that. Because what I do is not so much try to tell people that our technology is cool, but just be like so in love with it that I can't help but share it. I feel really bad for other people who are evangelicists and have to like talk about a technology that they don't really care about. Because like for me, it's like actually crazy how much I love what I do. I'm trying something a bit different with this talk and actually like wrote a speech instead of just winging it. So I hope it still sounds okay. But if it really fails, then I'll just make something up. Okay. Oh, the lights. Perfect. Okay. So I'm Isaac, and I'm an experience engineer at Leap Motion. I work exploring a newly discovered relationship with our hands. I'm intensely interested in communing with digital nature. And the tools that I use are Three.js, Web Audio API, and most of all, Leap Motion. Most of what I've done can be found at kabibo.com, where I've been working on constructing my own personal ice kingdom. Unlike our previous speakers, I have no idea what I'm doing. When they started talking about state machines, I was totally lost, and my understanding of equivalence rigorously stops at 2 equal signs. Don't worry, though. There's a reason you've been asked to sit here and listen to me for the next 30 minutes. It's because I'm addicted to coffee. I love coffee. Every day, it's the first thing that I consume, and many days, it's the last. I don't consume it because it's the hardest drug I use. I don't consume it because it makes me feel like a mental triathlete. And I don't even consume it because it tastes like the delectable blood of an angel. No, I love coffee because I love milk. I also cannot pronounce my I's, so it might sound a lot like milk. I love that milk is a different consistency than coffee. I love that it is differently colored than coffee, and I love that when I delicately combine the two, it creates the most beautiful pattern I have ever seen. It's actually to the point of obsession. I never get hot coffee. It makes the milk dissipate too quickly and isn't as likely to come in a clear glass. Regular iced coffee isn't even enough. I need cold brewed, condensed, New Orleans styled iced coffee. Only its viscosity will satiate me. At the coffee shop I go to, they make sure they never put the milk in themselves and always give me the container to pour it drop by drop. People can't tell if I'm super conscious of my milk consumption or just straight up weird. The later is obviously the true statement, but it's mostly just because I can't get over the mystical nature of chaos. It's kind of funny how this turbulence brings me peace. It's such a lonely joy, after all. Its haunting dance into nothingness is somehow melancholy in my mind. I think it could be because, to me, it's a firm reminder of the unshakable arrow of time or vacuum of space, which are in many ways terrifying. But it's just so damn beautiful that it can do nothing but calm me. Maybe it's because I can't unmix the milk and coffee. Maybe it's because when I mix the two today, they will look completely different than they do tomorrow. That one magical tendril that I witnessed on the first drop might be replaced with a dendrite, appearing only moments before the completion of the sepia solution. Maybe it's because any other individual touching the glass will create a totally different pattern. They will never see the same turbulence that I do. Maybe it's because each and every experience is only a single moment and a single branch of infinite possibilities, unique and miraculous as it is. Or maybe it's just the fact that after it's all mixed, I get to take that first sweet sip and feel the delicious nectar of caffeine flowing through my drug-addled veins. I hope it's the turbulence, though. This would be a much more interesting talk if it wasn't predicated on a deep physical addiction. Either way, that moment when I watch the milk mix, I find myself in a happy place. For that moment, rent is not important. That giant keep calm and carry on poster that is now the centerpiece of our living room doesn't bother me so much, and I forget how late I am to my 9 o'clock stand-up. I find the turbulence in that cup beautiful, and that beauty makes me happy. Not in an urgent way, in an important way. I want that peace all the time. I want to go to my happy place 10, 11, 12 times a day. And I've tried doing that with coffee before. It was a mistake. Luckily, as artists, as I believe each and every one of us are, we can create that happy place. And we can go to it any time we want. As magicians, every time a silly client tells us to use lime green to make the text pop more, we can just load up a web page and experience peace, experience turbulence. Here's the thing about turbulence, though. To get the detail you see in coffee, you need infinite computing power. To get each precise flume and dexterous wrinkle, you need to get all the way to the atomic level. We can get close, but we can't be exact. Sure, you have scientists doing brilliant work on subjects like Rayleigh-Bernard convection, but even in their brilliance, they fall well short of exact replication. The butterfly effect, as we have all learned from the brilliant scientist Ashton Kutcher, is quite a powerful one indeed. And he just looks so good in that picture. Floating point air is painfully inaccurate when compared with nature's uncertainty, Planck's length. In the end, if I believe that turbulence is the most beautiful art, nature is the most beautiful artist. It can not only create turbulence, but the snow-dappled mountains, the powerful rushing rivers, and every heart-wrenching sunset. Nature is awesome. Nature is so awesome, in fact, that I've seriously considered giving up computers to become a gardener. They are the artists, in my mind, who have chosen the truest medium. Anyone who has spent time in the bonsai garden over by Lake Merritt will certainly agree. The twists are more elegant than any Bezier curve could hope to convey, and the sheer detail of the turtled bark makes even the most processor-intensive physics simulation look like a crayon drawing. Any one of us could spend our entire life trying to create that turtled bark and still fall dramatically short of our goal. Hell, all of us in this room together could combine our superpowers and attempt to conjure a tree, and nature's shaders would triumph without competition. If we were physical artists, on the other hand, we could use the physical nature of our work in order to introduce some of the beauty of chaos. Back before I understood that computers gave you superpowers, I used to just spray paint on vegetable oil, splatter it on a canvas, and call that texture art. And it was, in many ways, more than what I create now. At an even higher level, I tried to sample the texture of an elephant's hide or a toad's skin. Sampling nature in this time was many times beautiful. It felt profound to watch the flow of the Voronoi cells of a dragonfly's wing slowly unfurl into existence as I painstakingly etched them into metal. But even this was a step away from the original. Even this was a simulacra. The further away I got from milk mixing with coffee, the more I gave me creative power and nature less. By doing this, I had to exert my own will upon the art that I was creating, and that meant that nature was doing less work and I was doing more. Since I'm lazy, and since we've established that nature is a much better artist than I am, creating in this way is ridiculous. I was trying to say the thing that I could both posit and execute was better than 1 trillion years of artistic honing. Generations upon generations of evolutionary pruning, a masterpiece older than time itself. The closest I could get was mimicry, or possibly borrowing. I could not understand how the paint mixed with the oil, but I could see that when I haphazardly threw them on the canvas, it created something that felt important. I could not make the elephant itself, but I could trace a picture of its skin, taking from nature what I could not create myself. In this way, to be good artists, to be good creators, we do not need to be good makers. Rather, we need to be good thieves. The Voronoi cells, the elephant's texture, and the swirling paint mixture were, after all, the creation of nature. And for me to harness it in my work and call it my own was to steal it from the world itself. This may seem like a cardinal crime, but as we've established, anything less is preposterous. What we do is another step away from nature. Typically, when creating a program, the functions we create and the tasks we accomplish have nothing to do with the logarithmic structure of fern or the Fibonacci arrangement of flower petals. It's all about paragraph tags and hrefs and targets equals underscore blank. We are the ones that place these tags on the page. We are the ones who create functions and methods, objects that use objects, and as we build up this shoddy Tower of Babel, we tend to forget how much more complex the system of an ecosystem is, and how much less energy it would take to destroy our work than that of nature. Even when we create recursive function and use math as the language of nature, adding one more layer of complexity can easily crash our computer, limiting our detail to quite childish standards. Let's not even begin to talk about the fact that we're limited to two-dimensional space and that no matter how many DPI your screen is, it is still crude compared to even the smallest grain of sand under the examination of our retinas. In this way, our medium is quite pathetic by any measure of detail. Even if we are to sample nature as a background or a texture, we are limited by pixels, memory, and rendering power. Instead of the rugged shape of an elephant's ear, we have to make spheres and cubes and make sure that the subdivisions are only of a certain amount, otherwise our rendering time will drop beneath the already pathetic 60 frames a second. Even Altered Qualia's and Mr. Doob's bump map face is dramatically less detailed than anybody in the crowds. This is not to say it is any less amazing. I think all of you can agree that that is actually absurd. It is just to say that whenever we do anything in our medium, we will fall short. When we try to mimic movement, when we try to create geometry, and most of all, when we try to imitate turbulence. I hope this is disheartening. It means that we have a long way to go. Our struggle may not be comfortable, but if we can somehow emerge victorious, what a victory it will be. Our medium is young, but if we can help it grow and we can use it to create, it means that we have accomplished something beautiful, and that accomplishment should make us happy. As well, there are certain things that are part of our medium that no other medium can claim to possess. There are certain parts of our medium that give us a fighting chance. First off, in our medium, stealing is in most cases not destructive. Because replication comes for free, sharing and utilizing others' code is widely accepted and expected. Coding is just socially acceptable thievery. This is not to say you should go out willy-nilly and jack IP, just that sharing is caring. You can see communities arise from this sharing, and it makes everyone involved more mighty. The best example of this that I know is 3JS. Because of one man, Mr. Doob's, fervent dedication to creating a useful library, many other of the power players of the WebGL community have joined in making a tool that lets even someone like me, who has no idea what they're doing, create something. It's more than just that, though. Others have let Mr. Doob call their work his own. In this way, Altered Qualia, B. Houston, ZZ85, Giro3, Wes Langley, and many, many others have added to the community with selfless dedication. With each additional commit comes more complexity, more substance, and more code to steal. It may be difficult to steal directly from nature, but in this way we can create complex enough networks of thievery that the stealing itself becomes its own organic being. For the demo that I will show you, I've stolen so much work from so many people that there's no way that I can have claimed to create it myself. I've only selected a mix of others' works and put it together in a way that I've not seen before. All work we do is not our own. It is that of our community. Even in the unlikely chance that you have built something using no libraries, the work that the V8 engine does in order to compile your code, and even more the work that Intel or NVIDIA has done in order to render your program, trumps any contribution that you could make to the overall success of your application. Anytime you think you have made something, you are wrong. You have channeled the organic power of communities, corporations, and people in order to manifest a creation of humanity. I can't explain exactly why, but the miracle of these different components coming together every time I refresh my browser makes me think of the mixing of milk and coffee that I love so much. Suddenly, my messy room, the deadlines coming up, the fact that rent was due 2 days ago doesn't matter so much, and I start drifting in mental space, marveling at the smallness of my own accomplishment as I consider how magnificent our species is. I forget the urgent and remember the important. It doesn't just stop at the channeling of humans, though. Our medium has something else that is spectacular: variables. Although I will never be able to make a face that is better than the one that nature can make, there's something else magical I can do. I can change the skin color. I can even change the color of the lights that shine upon the skin. And I get to do all of this with a single keystroke. In this way, I can create an object that maybe has less detail, but has more self-freedom than that which is created by nature. Although this goes a bit against letting nature do the work, there's something special about variables. They can be controlled by another manifestation of nature, data. In my mind, data is our most fierce weapon in the creation of that which is organic. Because it is so expansive, it allows us to pass through one piece of nature to another. Although this manifestation usually tends to be a one-to-one correlation, say placing population data on a globe, there's nothing to say that we can't recklessly link two uncorrelated phenomenon. Imagine a face whose features are distorted by the number of endangered animals per geographic unit. I'm sorry I didn't have time to make this, but I hope that you can concede it is at least possible. In this way, we can begin to create works which utilize data to create an interface between the natural world and ours. By figuring out ways to get real-life data, we get to make real-life applications, real-life art. There are so many sources of real-life data. To me, there's obviously infinite, but there are two that are the most important: what I hear and what I see. I'm not yet able to rig my eyes and ears up to a Thunderbolt cable, but in the meantime, there are two ways that I can begin to access these senses: the Web Audio API and Leap Motion. The Web Audio API is great because anytime I want to link audio frequencies to parts of an application, all I need to do is create a stream, create an analyzer, and call an analyze function on the update loop. That's all it takes to get access to natural data. The Leap Motion is great for a similar reason. All I need to do is create a controller, connect it, and now I have access to something that I can see, something as fluid and authentic as the movement of my own hands. Because of this simple access to data, I get to start doing strange things with code. I get to start saying, okay, make a face, but also just deform it based on the sound of my voice. Oh, and also so that when I see my hand turn, make the colors change. Suddenly, something that I've stole comes to life by funneling data from one place to another. Although I tend to fetishize the aesthetic, this fluid data is more than just a visual nicety. I've seen interfaces that feel more playful and organic than any I've experienced pre-Leap Motion and pre-Web Audio API. I've seen things created that were never before possible. I myself learned to 3D model and made a mug overnight. Thank you. Yeah. It's because all I had to do was reach my hand into space and use the senses that I love so much. Because many minds more brilliant than mine did find a way to mine the data, I get to lovingly thieve their work through robust and simple APIs. They make the data easy to thieve, and as creators, that is the kindest thing we could ask for. Additionally, because of their nuanced connection with natural data, programming with the Web Audio API and Leap Motion becomes a pleasure rather than a task. Although mimicking the binary click of a mouse may be less than ideal, new interfaces that deal with flow and movement and the full spectrum of human capability become possible. Because I can make frequency of my voice control scroll rate, or use the position of my hand to control the camera movement, I can readily change one piece of data to another. And this flow, in my mind, is miraculous thievery. It is because in our medium there are no units. Creating a 100-foot sculpture only means multiplying scale by 100. Linking gravitational potential to note frequency only costs a single line of code. If I want to change from XYZ to RGB, there's absolutely nothing stopping me. And that is where WebGL steps in. For a meetup on WebGL, I think you might think I would mention the technology earlier than 2/3 of the way into the speech. But I hope that everything up to this point will still apply to your creation, even if you never end up using WebGL. That being said, you should use WebGL. You should use it because 3D is ridiculously awesome. You should use it because you can make an entire presentation in it, and it doesn't take that long. But the biggest reason to me that you should use it is because shaders. Also, it did take that long. Now, I only learned that shaders were the truth and the light about 2 months ago, so please take the following with a grain of salt. I'm feverishly studying how they work and what they can do, but that being said, it's only been 2 months. This should give you a lot of hope, though, because if I can learn anything about shaders in 2 months, it means you can too. I'll try to talk about this a bit. It's a bit too much to talk about quickly, but I'll give you sources too. In the end, WebGL shaders do two things, XYZ and RGB. XYZ is referring to a vertex shader, which positions every single vertex in a geometry, which you can see here as a cube. And RGB refers to a fragment shader, which colors every pixel in that object. Together, the two can deform and color any shape until it looks nothing like the original. We could do a full speech just about deforming and coloring a cube in interesting ways, and I'm sure that if you searched on the internet, you could find exactly that speech. But we've got to remember, what we're here for is the coffee. To get there, we need to do a few tricks. Because we can sample textures into vertex shaders, we can easily exchange XYZ with RGB, basically placing particles based on the RGB value of a texture. Now I'm going to start with just a picture, where we take the RGB values of the picture and place them around based on the value of those three objects. So R becomes X, G becomes Y, and B becomes Z. Here we can see the pixels and colors turned to positions, and see that although there are these deep reds, the yellows actually have value that contains R, G, and B. So it reveals something fundamental about this picture that we may have not known before. We can take this a step further and sample a texture that we've created with a fragment shader. In this way, we can color each texture of a shader as we've done randomly in the middle, giving values from -1 to 1 for R, G, and B, and then placing each particle as it corresponds to its pixel in three-dimensional space. Then, by chaining together vertex and fragment shaders, we can create one fragment shader that talks about position and one fragment shader that talks about velocity. Once we link all this through, we can do something spectacular. A physics simulation done entirely on the GPU. What is so special about this is that all the calculations happen in parallel. In this gravity demo, every single particle is enacting gravitational force on every single other particle. We're talking millions and millions of calculations every frame. We're talking, instead of hundreds of particles, you have thousands, even millions. Now, I should have spent the entire speech trying to explain this, but there are already a few brilliant examples that you can look at. Mr. Dube's Sporel demo, which was part of the Google Christmas experience, is a great example, and he's released all of his code. ZZ85 Spark.js is absolutely sublime. ZZ85 also does a flocking demo in the 3JS examples, so check that out. And as well, SolWire's straight WebGL GPU particles. The tasks that they are doing are all different, but if you closely examine them all, you will learn dramatically more about GPU than I can hope to explain in this short time. However, with their knowledge aptly and lovingly stolen, I can move on to the Holy Grail, turbulence. To make my turbulence, I use something called curl noise. It is not actually fluid dynamics, and I've been told by a few math PhDs that it's a sin to even call it mimicry. It's smoke and mirrors, but then again, we are magicians. Now, the most beautiful example I've ever seen of curl noise was from the astute creator Eddie Lee and his demo artifacts, as you can see here. Eddie Lee is a straight-up mastermind, and if you've ever played Kyoto or Lotus, I'm sure that you will understand why. He elegantly navigates the issues I've discussed with digital creation, both by creating authentically organic shaders and by buying wholeheartedly into the fact that his creation cannot be natural and making it playfully simple. Additionally, he's awesome because he let me steal his code. He showed me how to mimic my turbulence, my happiness. I didn't just steal code from him. He gave it to me, free of charge and out of kindness. With this code in hand, I was off to the races. After hectically slapping together shader code into ZZ85's GPU particle simulator, I refreshed my page, and nothing happened. I did it again, and again, nothing. After multiple more hours of frustration that can only be known by someone who has tripped on a shoelace moments before finishing a marathon, I finally asked one of my other idols, Reza Ali, for help. Being yet another brilliant mind and another gracious soul, Reza sent over his curl noise code, which made me realize that I'd used an equal sign instead of a plus equal sign for the most vital part of the equation. I told you I know nothing about equalities. But with that bug fixed, I crossed my fingers, refreshed my browser, and there it was. My very first turbulent system. And by mine, I mean Mr. Doob, Alter Quelia, ZZ85, Eddie Lee, Reza Ali, and probably many of the people sitting in this room right now. Sure, it was no milk and coffee, and I know now that using more optimized code, I could get 10 times more particles. But it was a start, and that alone made me happy. I really think that this could have been enough for me. If I committed my changes, shut down my computer, and went to sleep, it would have been more enough creation to gratify my gluttonous desire for the important. But if I stopped, it would just be a frail imitation of nature. It would be dots algorithmically moving around the screen. And as happy as I was with those small white squares, it is after this point of initial implementation that our medium begins to shine. This piece of code is in my engine forever. Now I get to play. Now I get to create my happy place. Now I finally get to explore in a way that was never possible in the physical world. That sunset, though heart-wrenching, only happens once a day. It will never be the beautiful turquoise and magentas that I can so lucidly imagine it to be. Although I can watch the glowing ball from far away, I can never reach out and touch it. Yes, we are stuck in simulation. We are perpetrators of imitation. But in that imitation, in that mimicry, comes a new truth. It is a hyper-reality we create. That sun can not only set in the east, but it sings to us if we only will it. The stars are no longer a diamond curtain, but a playground. We can explore and experience that which is not possible. Nature may be a brilliant artist, but if we choose to create with its infinite power, we have to take on the shackles of physicality. Now, with WebGL, with access directly to the senses, we can begin to cast those shackles off. I'm no longer limited to my flesh self, and I can finally come to you as Kabibo, the ice mandala of the northern kingdom, floating in the darkness. Nature may want to keep me here on this earth, harnessed by my decrepit human form, but I refuse that requirement. I will create a universe where I can fly through the stars with the flick of my wrist, watch eons unfold with each harmonious ohm. I will reject common sense to make the impossible possible. I will create. I will leave you now with one more of our creations. Please sit with me, and as you watch its life unfold, meditate on what is important to you and what makes you happy. Think about what you will do as a miraculous creator and how you can harness the power of the entire human race to manifest your creation. As I fly you through our slowly dissipating universe, remember that although we will always be painfully limited as humans, we together have made something that allows us to be so much more. Without further ado, I give you We Over by Holy Other. Thank you. And check these out, too. I've never seen those so bright. Thanks for clapping so loud, you guys.
All right. Thank you, Isaac. That was pretty cool.
I don't know if
got your speaker gift for you. Here.
Oh,
No.
thank you so much. Wow. This is beautiful. Thank you.
All right. So while we rearrange the room real quick, please take a moment. I mean, you can stay in your seat or you can take a quick break. We need about 10 minutes to put the chairs up, and we'll start with a quick lightning talk, and then we'll have Q&A with all the speakers, and then we have the raffle prizes. So we're running a little bit behind schedule, but I think it was worth it. So we'll be back in 10 minutes. Okay. Thank you. All right. So we're going to get started with with a quick lightning talk that we couldn't do earlier, and after that we have a Q&A panel. So we're going to keep it to one question per person. You're not going to have multiple chances, and try to keep the questions a little bit brief and concise so that we can move on and get quite a few questions, and then we'll do the raffle. So people come in for a second. Okay. Looks like we got a quorum. All right. So,
okay.
Fabrice.
Thank you. Hello, I'm Fabrice. I work on Montage.js, and Montage.js solves in short, the collaboration between developers and web designers. And tonight we'll just show an instance of that with some 3D models styled with CSS. So if any web designer can trigger the WebGL power. So in this demo, okay. So here, the model, everything is brought, by the way, by GLTF, the standards I work on at Kronos. And you can play a little game where we have hidden 4 montage logos, and every transform and interactions are actually declared in CSS here. So it's actually a web designer who could code the game code. So you have different point of view. Even the mouse pointer, when you make over changes, and all that is described in CSS. So behind the scene, you have all the image-based it test and everything, but just magical, just exposed as CSS. So I'll show you a more elaborate demo now. Okay. So say you want to optimize the energy consumption in your house. You want to be green. You have some options here where you could just for you can choose between different furnitures, and here and here. So you have a very slick scene in movement thanks to WebGL. All the model comes from Collada, converted to GLTF. Everything here is integrated thanks to Montage.js. So everything you see and every interaction are made with bindings directly. So it's very easy. So here come another static point here. So that's it, a quick demo. Thank you.
Thank you. Thanks. All right, so see if I can still have the mic on here. There you go. Some of the speakers are still hanging out there. All right, so questions from the audience? And like I said, keep it concise, and let's get, so first question. Who's got a question? Yep, go for it. We don't have a mic for the audience, but yeah, be loud. We only have one mic there. Yeah.
Saw some really strong high performance stuff there, 60 frames a second, 30 frames a second, 60 in most cases. Where are the hardware, not Russell, this question for you, where the hardware is going to support that? Like, because we were at DevFest, we heard Google talking about 60 frames a second hardware coming out, one of the dark guys. I'm not going to say who it is, I'm going to get it right for it. It was a public discussion. We talked to our famous guys, and they didn't mention that, like, nobody had that. But then I saw it. So what do you see besides for WebGL, for UIs, offline and online, either core video, core audio, whatever, if it's iOS, it's Android, where do you see the hardware that's going to support true 60 frames a second, 40 frames a second, where you can't tell the difference on local systems or in the browser?
Yeah, so repeat the question? Or so Right. So the question is, where's the hardware in all of this? Like, are we lagging behind on the hardware side? What do you see coming around the corner?
Don is in the restroom. He should answer this. I think he effectively answered it. Here you go. Did you hear the question?
I did not hear the question. It's about hardware.
Okay. One more time.
One more time. What is the question?
Where is the 60 frames a second hardware? When is that coming? Is the question.
The 60 frames a second hardware.
The true 60 frames per second enabling hardware. When is that coming?
For PS4 or?
No, in general.
Just in general.
Guys,
Oh, okay. Well, I mean, you can hit that now. It just really depends on your application. So, I mean, it's there. You know, you can boot up the FPS tracker and actually see what you're doing. And you can certainly hit 60 FPS, but yeah, I'm not really sure what we're getting at here.
All right, I'm going to add to that. I think Don already answered it. Here's the thing. Any application you write can run at 1 frame per second on really good hardware. It's all about how you write the software. Don spoke about it earlier. So yeah, there's going to be some sensitivities. Some devices are going to run faster than others. But in general, I think you need to performance profile for any device you're building for, and you can get 60 FPS on anything if you build your application correctly. He doesn't want to touch that.
Next. 10-foot pole, anyone? So, yes.
I guess this is a me question. So the question was, can you browse WebGL content on the PS4? The answer is no, not at this current time. Don't look at me like that.
Follow-up, why?
I mean, you know, obviously it's, you know, we want to enable more and more for our browser. At this current time, you know, we don't enable WebGL for just general things on the web. That could potentially change at some point in the future, but I can't really say when or where or why that would be the case. So, you know, kind of figure I get this question, but, you know, very much apologize for my evasive answer there.
All right. Do we have another question? Yeah, go.
Right.
Two.
What's your name? Hi, Josh. Nice to meet you. I'm kidding. We've met before. Question is, has there been much acceptance of the GLTF format in the general web community so far, right? Answer, no, but there's a good reason for that, which is we're really not promoting it too much yet. I talk about it in my talks. Fabrice mentioned it in passing. It's a new format. In fact, we have not even published the specification yet, but we're doing all the work out in the open. The spec itself is written in a JSON schema that you can go look at. There's like 0 pros. Like if you want a tutorial on it, forget it. You're going to come talk to me and Fabrice or whatever. But it's all being done out in the open. We're building prototypes out in the open. Fabrice has got one on the Montage.js framework. I built one on 3.js that loads GLTF. I showed it to you tonight. So all that stuff's being done out in the open. But the Kronos group, and this is a Kronos project, these are the people who made the Collada format and the WebGL standard, in fact, are doing it as an R&D project that at some point we want to promote as maybe a new standard, essentially as the kind of format that you would do with Collada back in the day. You know, get all your data out of your modeling package and into an application, but this one for the web. We're going to do that someday, maybe this year, but we did not want to rush it. We actually spoke about trying to standardize this year. A game developers conference coming up in March. We want to get the standard all ready and get people using it and all that. And then Remy, who's not here tonight, Remy Arnaud, who created Collada, said, why don't we get it right first a little bit more, get developers using it, and then we'll start promoting it, and then we'll start trying to standardize it. So long story short, it's still a little bit early. I am having individual conversations with lots of people who want to actually try to build it into an application now, but we're talking about kind of a 0.8 version of the format, so really not cooked yet. So that was question 1.
Well, we only have one question per person.
Oh,
so
there we go. Sorry, Josh.
Come back to that one. We have other
We'll come back
people.
to
Go for it. Yep. I promised.
I mean, honestly, I.
Repeat the question.
Okay, so he was asking, if I actually had more time, what exactly would I do further on the PS4? I mean, I really felt as though I hit all the things I kind of wanted to hit in terms of the whole optimization thing. Obviously, there's a lot of other people's code involved because this was basically a port. I mean, if I were doing the whole thing, me, myself, and I'd probably avoid JavaScript and probably go with something like Dart, especially now because, at this point in time, it's better to think of JavaScript as nothing more than an assembly language and use the tools and languages you actually feel productive in. So in that sense, I feel a whole hell of a lot more productive in Dart, and I did kind of want to go that route, but didn't want to add any additional overhead because I was interfacing with a bunch of JavaScript code. Thank you.
All right. Other question in the back there.
I'll try to keep this brief. Okay. So the demo I showed earlier, the Unreal Engine demo, was done with this technology called Mscripten. Mscripten takes code that has been compiled by a C compiler or C++ compiler into what they call intermediate code. It's basically byte codes that ultimately get turned into machine language by the time the executable has been linked. So if you're building something for Windows or the Mac, you'll use a C compiler, and ultimately you'll get machine code, but it goes through this thing called LLVM, an intermediate code. Mscripten takes that LLVM and somehow miraculously turns it into JavaScript that can be executed in your web browser. The tool was built at Mozilla, the Firefox folks, and they actually have done a bunch of different ports and projects with it, the most notable one being this Unreal Engine level I showed you. They did this in a week. Now, I'm sure this was a week of like 5 people on each team from Mozilla and Unreal, Epic Games. I'm not, I don't have the details on that, but I'm guessing. I mean, because it's pretty involved. I am now currently working on an Mscripten project myself, so I could tell you firsthand. I went back and did something I haven't done and didn't think I would do for years, which was get a Windows machine. I'm even running Windows 8. I won't say any more. I got a C++ compiler. That was okay. I mean, it's been a few years, but I did it. I compiled stuff, and then I ran this Mscripten tool on it, and it actually is working, and I've spent about 2 weeks on this project I'm on. I can't say what it is. And it's not well documented. My biggest complaint, if anything, is the tools seem to work, but you got to spend a lot of time kind of trying to intuit what's going on. But what I showed you, that 60 frames a second, well, 30 on my machine, but I've seen it running on 60 on some higher-end hardware, does a great job. I mean, we're getting this really great frame rate from something that, if you think about it, I don't know if you know Unreal, the app itself, the games are built in a scripting language. So we not only have C++ code compiled into JavaScript, that JavaScript itself is running a language interpreter for Unreal Script, which the game was written in. So we have a cross-compiled application that's got an embedded scripting language interpreter running in it. And if any of you guys know what interpreters are, you know that's a big deal. And that was, I mean, you saw it yourself. That was kind of amazing. So long story short is Mscripten is great, but you've got to suffer through a lot of lack of documentation. And Google's your friend on that one. I mean, there's a lot of people out there who've suffered through the same problems as you, and that's what I've been doing this week. So there you go. What's that? Of Mscripten? Oh, there you go. Please. Not taking credit for that.
All right, question over here.
I just want to hear, I mean, all five of you, I mean, covering very different technical aspects, but what question should I be asking you a year from now? I mean, it's moving so fast. There's so much changing, and there's so many cool things happening. A year from now, how is it going to be different? What question should we ask?
Go left.
Yeah, well, no. You go ahead. You get started. I think. Okay, so me coming from the real-time communications aspect, I think.
You're going to be communicating from history.
No. Yeah, time. Yeah. So the first question, the question was, what is the question that I should be asking a year from now? What are the challenges going forward, right? So one of the biggest hypes these days is connected devices, right? This is where real-time communication plays an absolutely critical role. How it's all done, how it's all managed. We have these gazillions of devices out there. Another absolutely critical question in this space is security. Once you open up your home, you open up your health, you open up basically your personal stuff, that's going to be absolutely crucial. And then the question is, what happens when things just don't work? Like you are on a subway or you are on an airplane. These are kinds of the tough questions in our space.
And always will be.
I think in a year from now, I'm going to be asking this. Why are people still writing JavaScript to do basic stuff? Why am I not just authoring with tags? I mean, JavaScript's fine, or pick your language, Dart, whatever. Why am I not just creating content fluidly, just in a web browser, 3D, multimedia content, the way I used to, with some HTML tags? I mean, JavaScript's great, Canvas is great. God bless all these APIs. We wouldn't be where we are without them, but why am I solving the same problems I was last year? So in a year from now, if there aren't tags for doing your 3D and your other rich media, I'm going to start asking those questions.
Well, actually, with yours, I mean, some of the stuff with Polymer looks very promising. I believe there are actually some demos where you can do that sort of thing already and just sort of do markup in 3D. So it could very well be a thing.
But Don,
yep.
What will you do next year?
That is a very good question.
Don's boss is in the room.
Yeah, exactly. Well, I mean, more or less with the webs, where it's going, I'm very interested in how we can build better applications on the web. WebGL is certainly awesome, and I enjoy it, yet you're like, get to the point already. Thank you, Teo. I'm more or less interested in seeing where the web goes, how we're going to push it, and sort of what the new technologies are.
How are you going to push it?
Well, I mean, I think web components are really where the web is going to go, because developing with the DOM is pretty shitty. And we need to more or less keep pushing more of our apps to the web. I mean, it's a great idea. You get the collaboration, you get the mashups, you get all these things. And that's really where applications should be going. I'm very interested in kind of pushing, where 3D sort of fits into that space. So that's what I'm interested in. Is that sufficient?
Right. What I think is interesting here is that what we do now when we start defining these ways to work with the web and WebGL is that we have a great responsibility in doing so, because we will define how people will work it, and that means that we will define if this will be a good thing, if it'll be the next big thing or not. But it's also a great responsibility. It is a great responsibility, but it's also a great opportunity to do that. So in a year, I think we need to ask ourselves, did we succeed? And when it comes to the whole organic ecosystem kind of view on it, as you said, we need ways to push our apps through. We need ways to connect the publishers with the creators, And even if you don't know what you're doing, you should be able. Because he's, as you said, even people that have no idea what the web is or haven't seen a browser before should be able to get in touch with publishers if they have great content. So I think that's going to be a great big challenge in a year from now.
I'm probably just going to be wondering how I can make like digital caffeine so I don't have to go out and buy it anymore. That's it.
I think I'd be wondering, what's my spot on the waiting list for the next SFHTML5 event? All right, so I think we have time for one more question, and then we go off to the raffle. And for those of you in the overflow rooms, look at the camera, you'll see over there, you can come in here for the raffle to make it easier so we don't have to call out all that. So one more question. Who's got the final question? Okay, maybe your second question. No.
No.
All right, there was someone else getting up there. Yep, okay, go ahead.
None of us are actually on the Chrome GPU team, so there are some people hanging around from the Chrome GPU team. One might be hiding themselves in the back. So, yeah. Ken.
Yeah, ladies and gentlemen, for those who don't know him, this is Kenneth Russell. He's the WebGL working group chair, and he works at Google, and he makes WebGL that works in Chrome, which is awesome. So, Ken, you going to give us a sneak peek at WebGL 2?
Okay, so first of all, Tony gives me far too much credit. Where's Brandon and Vangelis? Okay, so those guys back there, please stand up and wave. So this is Brandon Jones, who did many of the really super cool WebGL demos, including iOS Rage in WebGL, who is now a member of our team. Thank you for joining. And Vangelis Kokevis, our boss. Please tell him how great we are. Thank you very much.
You're awesome.
Okay, so Tony gives me far too much credit. There's this joke about the parrot who's the chairman. It's like, oh, we don't know what he does. Just they call him chairman. It's funnier if you tell the joke. So WebGL 2, all right. So Cronus released a new version of OpenGLES that runs on your mobile phones, and most phones that are coming out now actually have this standard. It's a vast improvement over the previous version that's on previous generation of mobile devices and what WebGL is currently based on. At Google and at Mozilla and at Apple, we've been working on getting the baseline current WebGL really robust. We had some bugs in Chrome. In Chrome 29, you may remember, WebGL was not, it was flaky on Windows. That's a real problem because you developers cannot deploy your content in confidence, knowing that maybe it'll break on some browsers. Then you fall back to something else, Canvas, something 2D. You have to redesign your whole app because you can't rely on the new technology. So we've been, at Google anyway, we've been working on retrenching and really making sure that that baseline is robust, and we're almost done with that big push. So the next big push will be finish the WebGL 2 spec, really get to work on the implementation. And I said this in a meetup early, a year ago or 6 months ago, saying, wait 6 months. And now I'm saying, well, just wait another 6 months. But we're getting there. And I think that the testing infrastructure will be much better so that you can be guaranteed that you're going to be able to deploy this stuff immediately as soon as it's turned on.
What will it happen? What will it do when it grows up?
Take over the world.
Yeah, I think it'll probably reach mid-adulthood and then need some coffee with milk in order to stay awake or something like that. So it'll do its own turbulence simulations on the GPU. Pretty sure. Pretty sure.
Sorry, say that again?
It'll be doing its own turbulence simulations on the GPU for its own milk and coffee. Yeah, that's what WebGL 3 is going to do.
All right. Well, with that, we're definitely over time. I wanted to say thanks to all the people that tuned in on the live stream. We had several hundred people on the live stream. We'll be closing the live stream now, and we'll continue with the must be present to win raffle. And these guys are going to pick the tickets without